Hi everyone, warm welcome to the lecture on inequalities. So we'll straight away get started because there are a lot to discuss through this particular chapter. I'm trusting that by the grace of God, we are all good. You are good, I'm good, everyone around us are good. Let's get started. Let's get started straight away. So just to understand what are the fundamental blocks of inequalities, I'll share the lecture flow with you. What is that I'm trying to discuss out today? So sure, I'll start with the scope and importance of this. Then I will move on to the operations on inequalities, which is very, very core to it because that sets up the tone. Then we'll talk about the linear inequalities and quadratic inequalities. Both are equally important. In fact, the quadratic is where you can expect the questions in management entrance exams. And then there are 5 special properties of which each one of them is important. Some of them are very easy to understand because you already know about them. Some of them, yes, we'll try and learn and understand the basics of it. Then we'll go on to the integral solutions. That's both linear and quadratic and modulus. This 7 knowledge, there are about 6 or 7 things to discuss out today. So, but between all this, let's see how far we'll be successful, whatever the best possible. So I will try and cover through this particular lecture. Rest of it probably will take it some of the time. I'll let know based on how the time is, how much time will be available between now and to the entrance exams, right? Because we are 30 days to CAT, about 30 days to CAT. Let's see how much better we can squeeze in, how much I can help you, how much help you can seek. Let's try and see that. Well, let's start on this note. The scope is this very one of the very important topics because there are two fundamentals to any of the questions that we do. Either it should fall under equation or it should fall under inequation. These are the only two paths, right? Now, so of course, you may say that the equations are more equations, the probability in the sense like the magnitude or the number of instances where you get the equations is much more than the number of instances where you get inequalities. That is inequations. Yes, I agree with you. I agree with you. But then, so it's when we know that, okay, there are dichotomy, there are only two ways. Either I should end up writing an equation or I'll be end up writing an inequation. So from that perspective, understand that even this has a very significant role, whether directly or indirectly. So what we are trying to see today, explore today is we'll explore some fundamentals. We explore the direct implications of knowing the inequalities. Of course, all it knows the indirect implications would naturally follow from this, right? Now that becomes the autopilot mode. Automatically, you would be able to understand and figure out, and we should be able to do them with a little bit of practice towards the end. So here we go. All right, let's get started. So that's a scope. Therefore, if you look at the scope, this becomes another fundamental block. As much as equations are important, if not equally, right, to the other, no, if not equally, but inequations are important too, right? So that's a point I'm trying to convey. When it comes to the direct question, sure, you can expect about a couple of direct questions on inequalities about the topics that I'm talking about. Good, lucky enough, you might find up to four questions about these 5-6 things that I'm talking about. You might find as good as many as about 4 questions. Otherwise, two for sure. All right, from the topics that we are trying to discuss today, about 2 questions you can always expect from this particular topic. So here we go. Let's get started on this. Started with this, let me go on to the operations on inequalities. Let me start here on the operations on inequalities. So let's take something like this. There are already two things which are given to me. A is greater than B. It's been already told to me. Let's assume that A is greater than B. That's given. All right, no, that's given. No question about it. It's given. So then I have another K, which is a real number. Of course, A, B are also real numbers. A, B are also real numbers. Right, and I have another number K, which is also a real number. So let's talk about the addition rule. How does, if I add K to both the numbers, see what is given to me, understand it clearly. What is given to me is A greater than B. This is what is given to me. This is given. This piece of information is given. Now the point is A and B are real. Are they positive? No idea. Are they negative? No idea. All right. So therefore, so all I know is A is greater than B, because this can happen even like this. Hey, -2 greater than -3. Perfect. Perfect. I agree with you. -2 greater than -3. That's fine. Hey, no, 2 greater than 3. That's also fine because A is greater than B and both are real. That's also all right. So you may say that no, it's the other way around. Okay, you may say that okay, no, it is 3 greater than 2. 3 greater than 2. That's also fine. So both positive, both negative, one positive, one negative. Anything is possible in inequality, right? Now in the inequality. Now I have another number K, which is positive, which is K, which is any real number. Let's say what if I add K on both the sides, what happens? So just from your high school, A plus K and B plus K, I knew that A is greater than B. Okay, so if I add both the K on both the sides, K being positive or negative, irrespective of whatever is that particular real number, if I know A greater than B, if I add K on both the sides, the inequality does not change. My point here is what happens to existing inequality? It won't change. That's the point I'm trying to make. All right, that's a point I'm trying to make. All right, second, that's a point number one. Second one, subtraction. Okay, what if I subtract k from both the sides? What if I subtract k from both the sides? Point is, a inequality does not change yet. All right, still it does not change. All right, inequality does not change. This inequality remains as it is. No change. All right, now if you add or subtract, inequality does not change. Sure. All right, now we capitalize on these rules as we go along. Right now, these are pretty important elementary rules from your high school. Okay, next one. So what if I multiply this by k? Now I request. Now I say that, hey, please let me know whether k is positive or not, because you multiplied by k on both the sides. Now I request the author. I request, or I want to know. Request means what? I want to know, is k positive or negative? If k is positive, if k is positive, if k is positive, then the inequality does not change. What if k is negative? If k is negative, then the inequality would change. Inequality in the sense it was given a greater than b. Now I reverse it. Now I reverse it. Now I reverse it. Exactly same thing would happen with the division. Precisely the same thing would happen with the division. So if you consider the division on this particular problem, hey, what if I write a by k and I have b by k? Which would be greater here? Precisely the same thing would happen. If it is positive, sign no change in sign. If k is negative, there would be change in sign. That's about 3 and 4. Therefore, I'll package it into two ways. Addition and subtraction, no change in sign. Or multiplication and division, there may be change in sign. That depends on what? That depends on nature of the k. Or the multiplication factor, what you are multiplying or what number that you are dividing that k. It depends on that. Therefore, I want to know the sign. All right, I want to know the sign. Whenever you are multiplying and dividing, be mindful. Make one cross check in your mind. Do I know the sign of k? If I don't know the sign of k, then you cannot proceed with that particular question. All right, that's a point there. Okay, one last thing, reciprocal. Therefore, reciprocal, two things would happen. So if I say that, okay, 3 greater than 2, both positive, I'm taking the case 1, my friends. Solid, no, both positive. If I take the reciprocals 1 by 3 and 1 by 2, the sign would change. All right, sign would change. Similarly, if both negative, case 2, what if I have a minus 2 greater than minus 3? This is given to me minus 2 greater than minus 2 minus 3. Yeah, so let's put it like this. Let's put it like this, 3 greater than 2. Similarly, minus 2 greater than minus 3. Correct, minus 2 is better than minus 3. What if I take its reciprocal, minus of 1 by 2, minus of 1 by 3? Now the sign gets reversed. My point here is what? But both in case 1 and case 2, if the sign is same, A and B have the same sign, and A is greater than B, when you take its reciprocal, the sign would change. The inequality would change. Sign change in the sense it's not positive or negative. What I meant is the inequality would change. Inequality would necessarily change when in first two cases. Okay, what about the third case? Third case is what? When A is greater than B, it is possible that A is positive and B is negative. Possible. In that case, if I change the if I take the inverse of it, it does not change. Sign does not change. That is the point. All right. Now, therefore, I will again capsulate it into two parts. All right. For fifth part property, I will capsulate it into two parts. Are both A and B of the same sign, or are they of the different sign? That has a bearing on its reciprocals. I hope everybody is clear with this high school stuff. Of course, you would have studied little more properties there, I'm sure. But for me, these 5 are important. Probably you may open up your NCERT high school book or whichever the board that you have studied. If you open up that book, you will find 7, 8, 9, 10 properties based on the board. At least you will find about 8 properties or whatever. But others are pretty trivial. No, others do not require. Others we require. That doesn't require. These 5 things we need to be very, very clear. All right, we need to be very, very clear. Fair enough. All right. Now with this we can handle. My point is what? Why others are not important? These 5 will help us to figure out the other 3 automatically. It sets on the autopilot mode, right? So therefore we don't have to worry much about this. Fair enough. Let's all know that's a basic on this. Let's go to linear inequalities, my friends. On this note, let's go on to the linear inequalities. Firstly, let me introduce you to the brackets. You find in the exam 3 types of bracket. 1, the simple bracket. You find simple bracket, and you find square bracket, and you find flower bracket. These are the 3 types of brackets that you find. Okay, let me explain. What does it mean to you? All right, what does it mean to us? Say for example, all right, so on a number line, you have a number 2 and you have a number 5. you have a number 2 and you have a number 5. If you would like to tell me that, hey, all the numbers between 2 and 5 are fine, all real numbers between 2 and 5 are fine, but 2 and 5 should not be included, which means 2.1 is fine, 2.01 is fine, so all that is fine, right? But numbers between 2 and 5 are not included. That's when I represent this thought as, or this particular thought is represented as a simple bracket, 2 and 5. That's a thought. Inside the simple bracket implies that 2 is not included, 5 is not included, but all real numbers between them is included. That's the beauty of inequalities. Inequalities always tell us about the range. Inequalities talk about the range. It does not talk about one or two values. For example, if I write this here, x equation, I will write, my friends, x square minus 5x plus 6 is equal to 0. It gives me some specific values. It returns the returns on this. All right, what does this equation returns? It says that hey, x is 2 or x is 3. Simple. That's all the returns here. That's it. It doesn't tell that hey, all the numbers between 2 and 3. No. 2 or 3, that's it, period, over. All right, either x should be 2 or x should be 3, that is it. All right, on the other hand, if I change this, I'll discuss in a while here. Yeah, what if I change it from equation to less than? Oh, then it talks about the range. It is not 1. There are so many values it can take now. It's not about 2 values it can take. It's suddenly you realize that hey, it can take, all right, now millions and millions of values there, right? Now, because a lot of positive real numbers between them are possible. Same here, greater than, pretty similar to that. Okay, anyway, let's explore those thoughts later. My point with inequality is, remember, it's not about some specific set of values which are countable. In fact, it is about the range of values. It's about the range of values here, right? Yeah, that's point number 1. Let me go to point number 2, my friends. Say, what if I have 2 and 5 once again? All right, 2 and 5 once again, and I want to communicate to you that hey, both including 2 and 5 are fine. All right, all numbers between 2 and 5 are fine, and including 2 and 5 are fine. In that case, you represent it like this: 2, 5 and a square bracket. Now this says that okay, 2 is fine, 5 is fine, and all the real numbers between 2 and 5 are also fine. So implies, square bracket implies that the boundaries are also included. 2 and 5 are also included. The boundaries are included. Okay. On the other hand, if you say that okay, there is 2 and there is 5, and you say that okay, hey, only these two values are included. 2 is there, 5 is there, nothing in between, only, which means only 2 and 5, that's it, only 2 and 5. In the sense, like, you wrote something like x square minus 7x plus 10 is equal to 0. What does it mean? Hey, x is equal to 2 or x is equal to 5. X is equal to 5. What does that return? All right, now it returns this. All right, now 2 and 5. So how do I represent this now? Set. All right, 2 comma 5, which means no more, no less. X is equal to 2 and or x is equal to 5. Nothing beyond this. It doesn't take anything beyond other than 2 and 5. No other real number other than these two. That's what you are trying to communicate. Now these are the 3 types of bracket. Okay, so let's say, can I mix up some of them? Possible. Some of them can be mixed up in the sense, if I have a line like this, all right, between 2 and 5, again I'm sticking to that same example, 2 and 5, but this time, hey, 2 is included, all the numbers up to 5 are there, all the numbers up to 5 are there, all right, but then 5 is not included. How do I represent this? I represent like this: square bracket towards 2 side, means what? 2 is included. Then I will close it with 5, but it's a simple bracket, meaning 5 is not included, 2 is included, all real numbers between 2 and 5 are included, but 5 is not included. Likewise, all right, now likewise we can represent this. Okay, as we go along, we will put those thoughts in perspective. All these are high school thoughts. So but then I want you to be very, very clear with these 3 brackets. Therefore I thought that let me spend those 5 minutes so that like we are all clear about these 3 types of bracket used in inequality: simple bracket, square bracket, and flower bracket. All right, we need to be clear with all 3 types of brackets out there. Fair enough. Let's now go to linear inequality. Here, let's take up the first equation. Find the range. Look at the question. Find the range of values x can take, all right, such that 2x plus 3 is greater than 9. So what do you mean here? Just as if, just like an equation, you solve it, my friends. 2x plus 3 is greater than 9. Subtract 3 on both the sides. Subtract 3 on the both the sides. Inequality won't change. By subtracting 3 on both the sides, 2x is greater than 6. What your point here is, what you want to have x on one side and the other thing on the other side. That's the first point. First point is what? You subtracted 3 on both the sides. Some people mindlessly shift this 3 this side. Well, whichever way. I rather like go with the properties. I say that okay, subtract 3 on the both the sides. Then you will have 2x is greater than c. Now what? Divide by 2 on both the sides. Now the point is 2 positive? Yes. If 2 is positive, inequality need not change. If I divide 2 by 2 on both the sides, x is greater than 3. That's what you get here. How do I represent this on the number line? You take a number line. There are points here 0, 1, 2 and 3. Now you are saying that x can take all the values greater than 3. You go on and on and on. Till where? Till infinity. Therefore, what do you say here? So now how do you represent this particular thought? You may say that, okay, so therefore the set of values 3 comma infinity. That's one way of representing this particular answer. Why? Neither 3 is included nor infinity is included. It is greater than 3. It is greater than 3. Therefore, simple bracket. All right, you will put it as a simple bracket. Let's go to the next example. What is the meaning of the next example? What is change here, my friends? What is the change here? Greater than or equal to. That is the only change here. Greater than or equal to means what? This time, what is that you are trying to say? Now, this time you are trying to say that, hey, I'm including, this time I'm including this 3 as well. So how my answer option will change for the second question? It would change like this, 3 comma infinity. This is how you are one of the ways of representing this particular choice. Or x is greater than or equal to 3, or x is greater than or equal to 3, or the same thing can be represented by the simple bracket would change to flower bracket, because this time it is greater than or equal to, greater than or equal to. Simple. Okay, now the third point, let's come to the third question here. This is called as simultaneous linear inequality. Simultaneous, which means I want the value of x which satisfies both of them. See, for example, if you have 2x plus 3 is equal to 10 and you have 3x minus 7, let 3x minus 7 is equal to 13, let's say. See, what do you mean by this? Simultaneous. You got to get the value of x. Sorry, you call it 3 or 3y, let's say. 3x, 3y. 2x plus 3y is equal to 10, and then you wrote it as all it now 7x minus 7x 3x minus 7y, all it is equal to 3. Let's say I wrote something like this. Yeah, what do you mean by this? So you are trying to say that, hey, get me the values of x and y which satisfies both equation, not one of them. That's precisely you mean by linear simultaneous inequalities. Now look, it has to satisfy this word is and, it is not or, and it has to simultaneous this value as well. You pick one value of x, it should satisfy both. It shouldn't happen that it is satisfying one of them but it is not satisfying the other one. So when, because it's and means what? Intersection. What is the meaning of and in math, my friends? What is the meaning of and? And is nothing but intersection. Or is nothing but union. If you have the word or, it means union. And is nothing but intersection, right? So therefore we call it mathematically simultaneous linear inequalities. Fair enough. Let's take a look at this now. Let's go here. Let's examine this particular question quickly. Let's try. Let's see what does it mean to us. Therefore, first one is simple, right? We already dealt with this. 2x plus 3 is greater than 9. Perfect. All right. Therefore, we already understood this. X is greater than 3. How do I represent this on the number line? Let me put it here to perspective, my friends. Right. So here you have the values 0, 1, 2, 3. Whatever the values. Now you are saying that, okay, 3 is one of the values. Now you are trying to say that the values are anything that is greater than 3, which does not include 3. Till where? Till infinity. Of course, it goes on till infinity, dot, dot, dot. It goes on and on and on. Fair enough. Okay. Second one. Let's write the second one. 3x minus 2 is less than or equal to 19. From here, all right, now 3x minus 2. 3x minus 2 is less than or this. What I do? Add 2 on both the sides. Therefore, you say that 3x is less than 21. Divide by 3 on both the sides. E3 positive. Of course, it's positive. Therefore, is there a change in the inequality? Of course not. Therefore, you say that x is less than or equal to 7. Fine. So now therefore second one alone, independent, guys. I'm drawing the second one independently. So where is my number line? On my number line, 7 is. So what is that author trying to say? Hey, all the values less than 7. All the values less than 7. Till where? Till minus infinity. Now what I should be doing? Now I should be taking the common elements between the two. I got to taking the common elements between the two. I will draw one more line. Then I will take the common elements between the two of them. All right, I'll take the common elements between the two. What does it mean? Okay, I take here 3 and I take here 7. What is common? Because this is going away from 3. This is going, all right, now it is going towards minus infinity. But what are the common values? The common values are between, all right, now between 3 and 7. Between 3 and 7. All right, the common values are between 3 and 7. Is 7 included? Of course yes. Is 7 included? Of course yes. Therefore, how do you represent this particular thought, my friends? You will now come back and say that, look, the solution set is 3 not included, because 3 is not included, it's not included here. 3 not included, greater than 3, but 7 is included, therefore for all the values between 3 and 7 in which 7 included but not 3, we get both the inequalities simultaneously satisfied. That's about the linear inequality. I'm not going to talk more about linear inequality because it might not add too much of value to you, because we are all comfortable. This pretty elementary high school stuff, we all would be very, very comfortable with this. Yes, although there are instances where people may forget a little bit about the quadratic. There are about 4 or 5 things one should be mindful about, right? There are 4 or 5 things one should be mindful about. Therefore, I'll spend little more time out there in the quadratic inequality. Here we go. All right, now first let me give a briefing about this. Forget about this, guys. Like, if anybody can recall, please try and recall. Let me help you to recall some of the concepts involved in quadratic inequality first. Leave this question, we'll come back to this question in a while. So what did we learn here? See, if there is an expression ax square plus bx plus c, if there is an expression ax square plus bx plus c is less than 0, if I have this expression, this can be resolved as x minus alpha, let's say x minus beta is less than 0. Assume that ultimately you wrote it like this, which means there was a quadratic expression, a quadratic inequality. What you did with this, you wrote this as x minus alpha, x minus beta, in which alpha is less than beta. Which means alpha comes before on the number line when compared with beta. So now what do? You put a number line here. It's a parabola. We all know that, okay, this particular graph from the quadratic equation, it's a parabola. Okay, hey, what is the coefficient? What is the, let's say a is positive. Let's say that a is positive. If a is positive, the parabola opens upward. It is like this. The parabola opens upward. So now where is alpha here? Now this is what I mean by alpha. Where is beta here? This is what I mean by beta. Now listen to me carefully. Here. If it is less than, remember, all of your teachers might have told you that, hey, if you can ensure a is positive, your teachers might have told, now look, all this is always going to be positive here. All this is positive. This is always positive. We start here, we start the diagram here. This is positive, this is negative, and this is positive. Hey, what do you mean by this is positive? Now look, the graph is upward. If the graph is going upward, it is positive. Hey, what do you mean by beyond this particular point it is positive? Now look, graph is going upward, therefore it is positive. Hey, what do you mean by this is negative? Now look at the graph. Where is the graph here? Where is the line? Trace it. So it is lower below x-axis. This is x-axis, my friends. Below x-axis, what is the value of y? Negative. All right, now below x-axis the y coordinate is negative. That's what you mean by this. Therefore you don't draw all of this. How did you finally remember this? Simple, man. If there is a number line, I will take the number line, I will write alpha, I will write beta, I will simply start here. I will start on my right hand side corner. I'll start. That is always positive. This is negative, this is positive. When only one condition, a should be positive. That is it. A should be positive, and this is what you are going to do. If the inequality is less than, you will select all the values between alpha and beta. Therefore, what is the solution set for this, my friends? X can take all the values between alpha and beta. Simple, period. That's all you learn. In the sense, you remember only this. Sometimes you will not even draw the number line. You will say that, okay, hey, it's here, man, it's here. You will say that, okay, if my quadratic expression inequality is ax square plus bx plus c is equal to 0, then I'll quickly write it as x minus alpha, x minus beta is equal to 0. From there, I'll say that, hey, x can take the values between alpha and beta. That is it. This bracket, that is it. Hey, what was this, all of this story? Then this story is an explanation. This is an explanation to what I did here. How do I write x for x, all the values lying between alpha and beta? This is the undercurrent. Now undercurrent I don't have to really remember, because all right, now what you project is important to me. X values lie between alpha and beta. That is good. We are quickly sorted. That's it, done. So this is what I want you to remember from your high school. All right, high school, technically it's the class 9 or class 10th portion. This is what I want you to remember. Point number 2. Okay, that's point number 1. All right, that is point number 1. Let me draw point number 2 right here. All right, right here, let me do the point number 1. Let me draw the point number 2 as well. Say, for example, what if I have greater than sign? So I have ax square plus bx plus c is greater than 0. Fair enough. If it is greater than 0, all right, then you would say this. Let me write again as x. Again, a should be positive. That's the only condition. That is, coefficient of x square should be positive. Whether it is 1, 2, 3 does not matter to me. I need to ensure that the coefficient of x square is positive. That's what your teachers have said. Hey, what if it is negative? Why don't you multiply both sides by -1 and then make it positive? You said, what if it is negative, given to be negative? Fine, multiply by -1. Multiply by -1, it becomes positive. There is no problem there. But because you multiply by -1, change the inequality. Simple. Alright, if x square is not positive, onus lies on you. You make the coefficient of x square positive. That's what your teachers have clearly drilled, and I'm reminding you. Right, okay. So let's go here. So therefore, how you write x minus alpha, x minus beta is greater than 0. Great. All right, now let me explain this. All right, now let me explain this. What do you do here? Spot it, alpha and beta. Write alpha, beta here. This is positive, this is negative, this is positive. Greater than 0 means what, friends? Positive, right? So therefore all the values beyond this, all the values beyond this, how do I write this? You write this as minus infinity. There is minus infinity. Minus infinity to alpha is in my favor. Union and all right, now union this side. All right, now this particular side you are writing, how you are writing? Beta to infinity. Let beta to infinity, minus infinity to alpha, and then beta to infinity, union. All right, union. That's what you are trying to write here. That's what you are trying to write here. So how you remember from your high school? Simple. All right, you say that okay, this is all you remember here. So all this does not matter. What matters is, so from this graph you'll quickly write this as okay, x takes the values between minus infinity to alpha, union beta to infinity. All right, beta to infinity. This is all I wanted you to remember, beta to infinity. Right, now this was my discussion. My discussion precisely was, hey, do I remember this? And do I remember this? Do I remember this? That's it. These two boxes. Rest all is an explanation for these two boxes. Rest all is rest all is an explanation. Technically, what should get into your mind window? Do I remember this? Do I remember this? If you remember these two, then you are sorted. Right now, you are sorted. So what is that? One with a lesser sign, one with a greater sign. Fine. Let's explore these thoughts. Now we are very clear with these thoughts. Let's explore them. Right, let's explore them. Let's do it together, these questions now. This is the basic of quadratic inequality, right? This is the basic of quadratic inequality. Let's explore the thoughts. Okay, the question is right in front of you, my friends. Question is right in front of you. Why don't you take a few seconds? Why don't you take a few seconds and resolve it? Resolve it quickly within a minute's time. Resolve it within a minute's time. A minute is too much. Take your copies, quickly start. Don't wait for things to happen. Start doing. Good. All right. Let's do it. So what did you do here? You wrote this as x minus 5 3 times, right? 5 3 times 15. Therefore, x minus 3, x minus 5 is less than 0. So, okay, let me just do it for you once the number line. So, on the number line, one of them, all right, now alpha, x minus 3 is equal to 0. So, in the number line, what do you put, guys? Hey, what are the roots? Yeah, what are the roots? All right, now, so here, basically, what are the critical points? These are called as critical points. What are critical points? You do this in your mind. X minus 3 is equal to 0. Therefore, the critical point is x is equal to 3. You write a critical point. Similarly, you equate this to 0 in the sense x minus 5 is equal to 0. You put it like that in your mind window, and then you explore the critical point. What is the critical point? 5. Therefore, you say that 3 and 5 are the critical points. Then you will go ahead. This is all it now. This is independent of whatever you do. You simply say that, man, this is positive, this is negative, and this is positive. That's it. You simply write it there. Write it there. Why? Because you know that the coefficient of x square is positive. That's it. Coefficient of x square is positive. Start here. All right, start here. Write positive, negative, positive. All right. Now look here. What you want? I want less than 0. What you want finally? All right. I want less than 0, which means what? Negative. Less than 0 means negative. Where is the negative sign? Here. Where is the negative sign? Here. Therefore, it would have simply said that, okay, the values that x can take is all the values lying between 3 and 5. These are the set of values that x can take. Simple question. Simple question. Close this, friends. Everybody close this. In 10 seconds, close this. Close it in 10 seconds. Good. Same thing. Therefore, you here also you'll say that x minus 3, x minus 5 is greater than 0, right? Greater than 0. From here, you would say that x solid. Now x my in a critical point if you want. Okay, let me draw this once for you. There is 3, there is 5, and you would say, hey, this is positive, this is negative, and this is positive. Right, this is what you would have written from here. So what is that you are looking for? I'm looking for the positive values. Hey, where are the positive values? Therefore here are the positive values, this side and this side. Okay, this side till where? Minus infinity. This side till where? Infinity. Therefore what is that you are trying to say? You are trying to say that x can take all the values from minus infinity to 3 union, which means minus infinity to this part, union from where? Again 5 up to infinity. 5 up to infinity. Now look, this can also be written as x can take all the real values except minus all the values between 3 and 5. This is also fine. R minus, R stands for real. Here what x does not take, call it what x does not take. Let me show you. So all the real values it can take except what, my friends? Except this, a 3 does not take, and all the negative values here, this it cannot take. Therefore what did I do? I represented this 3 to 5, 3 to 5 including 3 and 5. This is also fine. Well, these are the two ways of representation. You be watchful and mindful how author is representing it, right? The first one is the most usual way, but we can't rule out the option that a second one they cannot do. They may do all the real values, that is minus infinity to infinity, all the real values that are there except the values lying between 3 and 5, including 3 and 5, right? That's the answer there. Fair enough. All right, now that's the answer. Let's go to the next one here, friends. Let's go to the next one here. How this is different? All right, how this particular third one is different? Third one is different. Third one. All right, now third one is less than or equal to. All right, less than or equal to. Fine, you would have done exactly the same thing because I'm taking the same example here. Because now I'm going to make some points here. X minus 3, x minus 5. This particular question is less than or equal to 0. So from here you would say that all the values. Okay, there is a number line here. There is a 0.3. There is a 0.5, and you say that okay, this time equal to, less than or equal to. Look at this, less than or equal to, in the sense, can it take the values 3? Yes, well, it can take the values 3. Therefore you are saying that hey, this can take all the values from 3 and 5, or this can take all the values from 3 and 5. That is the answer to third question. Now look at the fourth question. What about the fourth question? Fourth question also, he has already written it. X minus 3 is here, x minus 5 is here. Go to the number line. Let me go to the number line, put the critical points. 3 is a critical point, 5 is a critical point. My point is, hey, it need not be x minus 3 into x minus 5. I'm okay with x minus 3 by x minus 5. I'm okay with this also. I'm okay with this also. All right, now x minus 3. I got the critical point. 3 is a critical point. 5 is a critical point. Very good. I have 3 critical points. But the point here is, hey, can I make x is equal to 5? Now look, that's where the domain. Is it in the numerator or these? All right, now critical points. All right, I'm getting from the numerator or am I getting from the denominator? That matters. That matters. Now look at this. All right, when this is less than or equal to 0, that's fine. But can the denominator be made 0? Can I give x is equal to 5 here? Denominator becomes 0. If denominator becomes 0, then this inequality becomes indeterminate. All right, it becomes indeterminate. Therefore, what is that you are trying to say? Look, all right, I cannot include this 5. I cannot include this 5. I can include this 3 because x minus 5 is in the denominator. I cannot include this. It's precisely the same question, friends. Here it is x minus 3 into x minus 5. Here x minus 3 into x minus 5. X minus 5. So therefore, be mindful about division. Be mindful about division, in the sense, if there is something in the denominator, okay, rather than division, put it as denominator. If there is something in the denominator, be mindful, denominator cannot be 0. All right, therefore theoretically we know that okay, less than or equal to 5 can be included, but 5 cannot be included. Therefore, how do you write the answer option this time? 3 is included. How do you write this response? 3 is included but not 5. 3 is included but not 5. All right, this is how you put forth your response, right? Yeah, okay, all of you got this. Being mindful about denominator is my point. Here we go to the next one. Try this, my friends. All of you try this. Yeah, you sorted. Okay, so what this question say? Find the range of values x can take such that this particular question, right? Now, so this we already done. This we already done. Only the sixth one is what you got to be doing here. The sixth one you got to be doing here. Denominator part is sorted. Okay, now what is this difference? So now can I say that, okay, hey, critical point is 4 minus 4. One of the critical point is minus 1. See, because you see x plus 4, you see x plus 1. No, you can't do that. Reason being, what is the reason being? Look, so far whatever you did after the inequality, it was always 0. All right, so far whatever you did after the inequality, it is always equated to 0. Take a look at this particular question one by one. All right, take a look at this. After inequality, all right, just focus on what is that, all right, on the right hand side of the inequality. I want you to focus on the right hand side of the inequality. It was given to me as 0. Second question, what was given to you? All right, in the second question. All right, now here also it was given to me as 0. In the third question, if we go there to the third and the fourth question, say this was given to me as 0. It was given to me as 0. But then suddenly what happened here? All right, in the sixth, all right, what happened in this particular question? You are seeing that, hey, it is greater than or equal to 2. Point is, first it should be 0. That's my first point with the question number 6. I want to look at the question number 6. What is given to me, friends? It's given to me x plus 4 and x plus 1 is greater than or equal to 2. How do I make it 0? Subtract 2 on both the sides. X plus 4 divided by x plus 1 minus 2 is greater than or equal to 0. Okay, can I apply the tactics on this? Of course, yes, you can apply the tactics on this particular equation. You can apply on this. All right, you can apply on this. Okay, so you can apply on this. So therefore what do you do on this? All right, now therefore how do we proceed? How do we get this done? So all you get this done is, see, look, all right, now you can say that, okay, I will multiply this by x minus 1. I multiply throughout by x plus 1. My point is, if you multiply throughout by x plus 1, I have a problem. Yeah, why you want to multiply throughout by x plus 1? Because in the denominator, this belongs to only one part. It does not belong to this part. So therefore, you decide to multiply x plus 1. Point is, if you multiply by x plus 1, my question is x plus 1 positive or negative? Why you want to know it is positive or negative? Because based on that, my inequality is going to change. If x plus 1 is negative, my inequality becomes less than or equal to. If you think x plus 1 is positive, it would remain greater than or equal to. Therefore, what I should be doing? Why you want to multiply by x plus 1? Rather, multiply both sides by x plus 1 whole square. What is the advantage? X plus 1 whole square will never be negative. Can it be 0? Fine, that's not a worry to me. All right, 0 does not change my inequality. What changes my inequality is when you make x plus 1 negative, that's when it changes. But x plus 1 whole square, it is non-negative. X plus 1 whole square is never negative. Therefore what? If I multiply both sides by x plus 1 whole square, then I have no issues. Perfect. Let's see this. Therefore, if I multiply both sides by x plus 1, how my inequality would change, my friends? You will write it like this: x plus 1 whole square times of x plus 4 divided by x plus 1 minus 2 times of x plus 1 whole square is greater than or equal to 0, because 0 into x plus 1 whole square is 0 only. You can write that step. Hey, this side also I will write it like this. Write it, but ultimately it is 0. 0 into this is 0. Right, that's where you end up with. Now what do you do? Simplify this. If I simplify, what do I get? X plus 1, because 1 x plus 1 gets cancelled with the power. Therefore x plus 1 and x plus 4 minus 2 times of x plus 1 whole square is less than or equal to 0. Now do what? This is a quadratic equation. So from here it boils down to your earlier method. Okay, my point here is what? Hey, my point here is very simple, friends. Well, if there is a number other than 0, all right, now subtract both the sides by that number, bring it down to this shape. This is the first stage. Bring it down to 0 and then attack this. Okay, let's solve this. Let's solve this. Therefore, what you are writing here? X square. I'm resolving this bracket. X square plus 5x plus 4 minus 2 times of x square minus 2x plus 2x plus 1 is greater than or equal to 0. All right, now something like this would have written. Now simplify this. All right, therefore you would say that minus x square. All right, minus x square, 5x and then minus 4x, therefore plus x. All right, plus x. And then you have minus 2. You have minus 2 and plus 4, therefore plus 2. Therefore plus 2. Right, yeah, plus 2 is greater than or equal to 0. You are getting something like this. All right, you are getting something like this. Now what do I do? Multiply throughout, because I said that a coefficient of, always keep the coefficient of x square positive. Remember all my points, because this question is a kind of a summary question. Remember all my point. I said that coefficient of x square should be positive before you apply my rules. Therefore what I do? Hey, why don't I multiply both sides by minus 1? Multiply both sides by minus 1. Sure, then it will become x square minus x minus 2, x square minus x minus 2. What should happen to this inequality if you multiply by a negative number? It should change. Less than or equal to what? 0, because 0 into minus 1 is what, my friends? 0, 0. Okay, now resolve this. Let's resolve this. This I can write it as 2 1 time 2, therefore I can write this as x minus 2, and then I can write it as x plus 1 is less than 0. Very good. All right, therefore now what is the critical points here, friends? What are the critical points? Critical points are minus 1 and 2. Critical points are minus 1 and 2. Job is not yet over. Job is not yet over. Be mindful about it. All right, yeah. So let's see now what is left. Job is not yet over. Now listen to this. How was my question? Where is my x plus 1? X plus 1 is in the denominator. Now look at x plus 1 denominator, which means x cannot take the value called minus 1. X cannot take the value called minus 1. It cannot take this value because although you have the sign less than or equal to, it cannot take, because this is plus, correct? This is minus, this is plus, implies, hey, it cannot take minus 1. It can take all these values and this. Therefore, now you are trying to say that the values that x can take for this particular question is minus 1 up to 2, but minus 1 is not included, but 2 is included. Minus 1 is not included, but 2 is included. Now, this is how your solution set would look like. All right, this is how your solution set would look like. So here we go. All right, now this is about this particular question, my friends. This is about this particular question. I hope everybody understood. 2-3 things we spoke about this. All right, one, we said that, hey, after equal to sign, there should be a 0. If there is something else, ensure that you bring it to the stage of 0. That's point number 1. Second thing is what we said that, hey, ensure that the coefficient of x square is positive. Hey, what if it is negative? Multiply by minus 1 and change the inequality, and then come back and change the inequality. Once you change the inequality, fine, you got this particular stage, you drop the critical points. Check, is any critical point is making the denominator 0? Check the critical point, right? You understand that, hey, if I put x is equal to minus 1, my critical point in the dollar, my denominator is becoming a 0. What is that? A denominator check. Denominator can never be 0. Therefore, you ensure that denominator, all right, now if I put x is equal to minus 1, denominator is 0. Therefore, you are saying I will not include minus 1, rather I can include 2. All right, these are the steps involved. 3 good points you revised about the quadratic portion out here. Now these are the points you need to be mindful about, right? These are the points you need to be mindful about. Good. Let's go to the next one. 7. Let's go to the 7th one. Let's go to the 7th one. Okay, I will give you a minute. Resolve both 7th and 8th, my friends. Resolve both 7th one as well as the 8th one. I'll give a minute's time for you. Resolve, because all points are made. I'm just checking through this, and the hints are also written there. Hints are also written. Resolve. Yeah, it's time. All right, let's do it together. Do this together. So what do you do? All right, now, so look at the numerator. Look at only the numerator part, the quadratic inequality in the numerator. How do you resolve this? You write this as x plus 2, x plus 3. Okay, what's in the denominator? How do you resolve that? The denominator portion of it. How do you resolve the denominator portion of it here? So you write this as x, that is 12 and 3, right? Therefore, you write this as x minus 12 and x plus 3. And you write this as x plus 3, right? Just give me a second. Right, x plus 3 is what? Greater than or equal to 0. X minus 12, x plus 3 is greater than or equal to 0. Now you will have this urge. What is that urge? Yeah, I will cancel this. I will cancel this. Therefore, what you will say, hey, I have 2 critical points. Therefore, you say that, man, I have 2 critical points. What are the critical points here? -2 is a critical point and 12 is a critical point. Why -2? Because is this 0 here? Already you see the other side is 0. Perfect. The other side is 0. Absolutely no problem. Okay. But then x plus 2. Alright, now from x plus 2 is equal to 0, you get -2 as the critical point. You equate x minus 12 is equal to 0, you get 12 as the critical point. So far it is fine. Alright, now all are fine. But the point here is, now listen carefully. X plus 3, you don't cancel it. Rather what you see is, hey, I have the same fellow x plus 3 here, both in the numerator and denominator. Keep it out, which means that fellow is there but not there, there but not there kind of situation, right? Yeah, so therefore you say active portion is the square bracket. What I'm writing here is the active portion greater than or equal to 0. Therefore what you should be doing, what I meant is, hey, keep this 3 here. Let keep this -3 here. Now you got to still keep this, keep this particular number. Now x plus 3, that's what you are writing here. You still got to keep that -3 here. Don't ignore that fellow. Hey, why that -3? Now look at this critical point. What is x plus 3 is equal to 0? -3. Keep it. Okay, but then don't count it. I'm using a different ink. Reason I'm using a different ink is don't count it. He's there, but don't count it. -3 is there, but don't count that fellow. Don't count that fellow. He's there, but not there. That's a kind of situation. That mute. He's basically mute there. Alright, that's a point. Okay, what does it mean? Let me come to this. This is positive. This is negative. Anything after plus 2 is positive. Anything after plus 2 is positive. Plus minus plus, because I need to start here and I will write plus minus plus. Okay, hey, what is the sign here, friends? Greater than. Greater than means what? Positive. Very good. So I will consider all the values here, all the values, because it's less, greater than or equal to, fine. 12 is included and I'm going up to where? Infinity. Good. A -2 is included. I'm going up to where? Minus infinity. Therefore on the face of it, it looks like, hey, all the values from minus infinity to -2, minus infinity to -2, that is -2 included. All right, minus here, minus infinity here, from minus infinity to -2 included, union all the values from 12 included up to infinity. Right? This is what you do ultimately. Minus infinity to -2 and 12 up to infinity. Perfect. But hey, why you all mark this particular number called 3? Why did you mark this particular number? Because it cannot take 3 as the value. Hey, why it cannot take 3 as the value? Now look at this, friends. In this particular case, so in this particular case, x plus 3 was in the denominator. If you write x is equal to -3, then the denominator becomes indeterminate. Therefore you are trying to say that minus, you are writing a flower bracket. Inside that you are writing it as -3. Inside that you are writing it as -3. That critical point, you are saying that, hey, look, this critical point is not included. All right, everything is fine. So in the sense, hey, while you are doing the cancellation, be mindful. Simply don't go and cancel. Hey, don't rub it off. It is there. So come back, mark that critical point, and remove that critical point. Come back. All right, write the range as if it is not there. Write every answer as if it is not there. But towards the end, come back and remove it. Why remove it? Because if you use x is equal to -3, which means in this, if you use x is equal to -3, denominator becomes 0, thereby it becomes indeterminate. All right, thereby it becomes indeterminate. We can't make the denominator 0 ever, right? That's the point with question number 7. Fair enough. If all of you would have written this particular portion, then it is perfect. Your fundamentals are very, very clear. You understood that, okay, denominator should not be made 0. That's a point there. Okay, point number 8. Let's come to the 8th question. So 1 plus x, 4 minus x is this. Okay, so now I said that, hey man, coefficient of x square should be positive. Technically we always write x plus, which means I look at this, I will write this as x plus 1. Did I do any change here? Absolutely no change. I will look at this, I would rather want to write this as x minus 4, and I want to ensure that the coefficient of x is positive. But if I want to write 4 minus x as x minus 4, what did I do? I multiplied this by -1. If we multiply by -1, that is what happens, which means you are multiplying this inequality by -1. If you multiply inequality by -1, what happens? The inequality changes, therefore less than or equal to 0. This inequality would change. Because why? Because I always wanted the coefficient of x square to be positive. That's a positioning. I want always that to be positive. Therefore, you drop the critical points here. So less than. Therefore, you say that my answers are all the values between -1 and 4. all the values between -1 and 4, which is included. Simple. By now I taught you how to use the number line, etc. My point about this question was not writing this line. My point about this question was ensuring that the coefficient of x square is positive. Coefficient of x square is positive. Good. That's about the summary of the quadratic inequality in totality. I reminded you about all possible points where people falter. Now looking at this, you got to consider the practices, etc. All that is there, but I illustrated, I made the points very clear that how you need to be mindful about your denominator while cancelling, how you need to be careful about certain parameters. All right, now, so how to ensure that the coefficient of x square is always positive, so that you can write your responses in a standardized format, right? These are the points I wanted you to recall. All right, recall there. Okay, so now let's go here. Special properties. I'll talk about 5 special properties, my friends. I'll talk about 5 special properties. One of them, in fact, I'm interested in the point number 5. I'm not interested in 1, 2, 3, 4 because they're really elementary and which will be top of that. Technically, what happens is the point number 5 is something which technically skips the minds of the people. Point number 5 kind of gets skipped. 1, 2, 3, 4 would be pretty clear there. Okay, 1. Nevertheless, we can take a look at this. A power n, b power n is always divisible by a minus b. For example, something like a cube minus b cube. A cube minus b cube is always a minus b times of. You can write, of course, hey, I know this how to write it, no problem. You can write this as a square plus ab plus b square. That's fine. If I write this as a raised to power 23 minus b raised to power 23, okay, I can write this as a minus b times of something. You can write that. That's not a worry. Can I write what comes inside of this? Of course you can write. I'm not debating on that. My point here is, okay, as long as I write a minus b, my job is done. It is definitely divisible by a minus b and little more. Whatever is that, I'll let know that you write in the bracket and its factors. Okay, that is about point number 1. Point number 2, similarly, what if I have a cube plus b cube? We always know that this can be written as a plus b times of something. That's something you know here. My point is, what if I write a raised to power 23 plus b raised to power 23? Hey, it is still divisible by a plus b times of something. So that's always a plus b. Good. Hey, what if I have a raised to power n, b raised to power n, where n is where n is even, because the first two were odd. This is even. So technically, a classic example is a square b square. A square minus b square is divisible by both a plus b as well as a minus b. Is all definitely divisible by a plus b as well as a minus b. Hey, what if I write a square plus b square? It depends. Cannot say anything because you never wrote anything for this, right? That's about the point number 4. Okay, now all these are hygiene factors. 1, 2, 3, 4 are pretty hygiene factors to me. I'm not here to discuss those things. It's not about that. Point about today's lecture was about the point number 5. All right, it's about the point number 5. Yeah, what is this point number 5 talking about? If it is a power n, b power n, c power n, d power n, in which n is odd. All right, in which n is odd, it is always divisible by a, b, c, d, provided a, b, c, d are in AP. Let me take a simple example here, friends. Let me take a simple example. Hey, what if I have 23 raised to power 23 plus 25 raised to power 23. Then I have 27 raised to power 23. Then I have 29 raised to power 23. Now you can definitely ouch and say that, okay, now look at this. What is this here? The common difference is 2 plus 2 from this term to this term. Add 2 from here till here. You add 2. Hey, what about the power? The power is odd. I could definitely say that, look, this would be definitely can be written as 23 plus 27 plus 27 plus 29 times of something. In other words, it is always divisible by this particular value. Right? Yeah, it's always divisible by this particular value. What is this? 104. All right, what is this? Nothing but 104. It is 104 times of something, which means this particular number, given number, that is 23 raised to power 23, 25 raised to power 23. All right, now this is definitely divisible by 104 or its factors, 104 or its factors. Okay, that's a point I wanted to make here. Point number 5 is what I want you to register in your mind. All right, what I want you to register in my mind. Here are a couple of questions. I just want you to do only the last question. I want to do only the question number 3. Yes, friends, go ahead. Quickly let me know the answer for the last question. Only 3. Don't bother about 1 and 2. 1 and 2. That's all. You are already on top of that. Only question number 3. Let's do 3 automatically. 1 and 2 gets covered. Do 3 quick. Perfect. Very good. So here you said that, hey, are these in AP? 15 to 17 is plus 2. 17 to 29 is plus 2. here again the plus 2. Are the powers odd? Second check. Are the powers odd? Yes, the powers are odd. If that's already, if the numbers already, if the bases are in AP and the powers are same, all right, then you would say that it is definitely divisible by, all right, it's definitely divisible by 15 plus 17 plus 19 plus 21. All right, 21. It's definitely 21. So therefore you would say that, okay, this is nothing but 72. You say that this number is definitely divisible by 72 or the factors of 72. So look, if the number is divisible by 72, then the number is divisible by 1 also, because 1 is the factor. Then the number is divisible by 2 also, correct. The number would be divisible by 3 also, correct. The number would be divisible by 36 also, correct. Therefore what you meant, when you know that the number is divisible by 72, it is divisible by all its factors as well, not just the number and all its factors. Therefore you would say that is 5 a factor of 72? No. Is 7 a factor of 72? No. Is 8 a factor of 72? Yes. Is 9 a factor of 72? Yes. Therefore your final answer becomes E. All right, therefore all right, because it is divisible by C and D, your answer becomes E, more than one of the above. Sometimes if they might write all the factors of 72 and create the answer choices, all of the above. Fair enough, that we can navigate. That should not be a problem to us, right? My point here is I need to be very clear about if my bases are in AP, and the difference is 2, it is always divisible by this. This is the point I wanted you to be clear with. If there are 4 terms, number of terms should be 4. There's a first term, second term, third term, and fourth term. If there are 4 terms, this phenomena is always true. This phenomena is always true. Fine. All right, now all of you got this particular point, I guess. Let's go to the second property, type 2. Second property, type 2. Guys, this one, whatever we did, all right, now this is a kind of a typical CAT question. CAT or any management entrance exam for that matter. It's a typical question. Therefore, we are paying special attention as properties or whatever the name that you want to call. I want to number them and remember them at the end of the day. That's my whole idea here, right? That's my whole idea. Let's go into this question. This is built on this particular algebraic identity. See, what happens is this identity skips our mind. That's a whole problem. So this should not skip our mind, because this is very, very important when it comes to inequalities. This is very important. This property is important to us. Right? What is this? It's not a property, it is algebraic identity. Just like you remember a plus b whole square, a minus b whole square, this also should be remembered. A cube plus b cube plus c cube minus 3abc is nothing but a plus b times of this. This identity as it is important. Today my parameter is in which if a plus b plus c is equal to 0, then what happens? If this is 0, 0 into anything is 0. All right, 0 into anything is 0. Therefore this is equal to 0. Therefore you say that a cube plus b cube plus c cube minus 3abc is equal to 0. Therefore ultimately it becomes this. A cube plus b cube plus c cube becomes 3 times of a, b and c, provided a plus b plus c is 0. If this condition is true, I can write a cube b cube c cube as 3 times of abc. Perfect. Let's try this. All right, let's try one of the examples. Let's try the first one. See, look at this. What is given to me? 72 whole cube. Now see, point is 72 whole cube to calculate is difficult, right? That's the whole idea there. You can sit and calculate, but then you will not have such liberty of time. See, 55 whole cube. So 55 whole square doing is easy. For 55 whole cube, again, you will take additional time. Similarly, 17 whole cube. Doing all this is now, so evaluating them and then trying to find out is always a challenge. Rather, what you do now, look at this. Okay, first term. All right, now n is written as, if n can be written as a square a cube plus b cube plus c cube, in which a plus b plus c is equal to 0. Then you can write that then n is also nothing but in which if a plus b plus c is 0, then n is nothing but 3 times of abc. Whatever be the abc, how large, how small, does not matter to me. Okay, go here friends. What is my a value here? My a value is 72. Okay, what is my b value here? Minus 55, because it is all right, now abc are positive there. Abc all right, plus is the sign between them. Therefore I am writing the value as minus 55 cube. All right, b is minus 55. Yeah, what does minus 55 cube becomes? Minus of 55 cube. Good. All right, that's how I write my b. Yeah, what about my c? I will write it as minus 17. Check, my friends. Is a plus b plus c is 0 or what? If not, to solve this question, you have to cube this. But then is a plus b plus c 0? Absolutely, a plus b plus c is 0, because a is 72, b is minus 55. See, this is 72, b is minus 55, c is minus 17. Is this 0? Perfectly, it is 0. Therefore, what is the value of n? This is n here. So how can I write my n? N can be written as 3 times of, what is a? 72. What is b? Minus 55. What is c? Minus 17. Together, it is 3 times of 72 and 55 and 70. Okay, because minus into minus is plus. Here there is a minus into minus, which essentially becomes plus. All right, now that's my n, which means this entire value here, all right, this entire value, without really cubing them and making them cumbersome, I comfortably express this like this. I comfortably express this like this. Now the question is, which of the following, all right, n is divisible by which of the following pairs? All right, which of the following divided? He says that hey, it is divisible by 15. It is divisible by 15. He's written the two terms at a time, 15 and 25. All right, it's divisible by 15 as well as 25. So let's take a look. Is this divisible by 15 here? This is the number, this is n here. So point is, all right, now is this divisible by 15? 15 means what? It should be divisible by 3 and 5, correct? 3 gets cancelled here, 5 goes out here. So therefore, is it divisible by 3 and 5? Of course, yes, 3 and 5. This is fine. But is this divisible by 25? Let's take a look at the second part. 25 means what? 5 and 5. This 5 cancels here. But do I have another 5? No. Therefore, this 5, no. So therefore, you say that it is divisible by 15 but not 25. Divisible by 15 but not 25. Therefore, choice A cannot be my answer. Great. Let's go to choice B. Let's go to choice B. Choice B is what? Is it divisible by 16? Let's check 16. 16 is what? 6. All right, 16. No, 16. None of these numbers, because the powers of 2's are here. Powers of 2's are here into this, right? Yeah, there is 8 there, 16 is not there. Therefore, you would say that 16 cannot divide. Does 17 divide? Yes, 17 can divide this directly. Therefore, B is not my answer, because 16 does not divide, but 17 divides. Okay, let's go to C, my friends. 15. Is this divisible by 15? We already looked. There is 3 here and there is a 5 here. Perfect. 15 is fine. Hey, is this number divisible by 68? Is this number divisible by 68? Number divisible by 68. Hey, what is 68? 17 into 4. Yes, 17 is here. 68 is what technically? 17 into 4. That is 68. Okay, 17. Oh yeah, 17 goes on this particular side. Hey, what about 4? 4 divides this. 4 divides this. Therefore, you say that 68 divides this. And hence you say that C is my answer. Ultimately, C is my answer. Right? C is my answer. Because you know this property of A. The numbers were 72 cube, etc. But you had no idea how to find 72 cube. In the sense, it takes time. We can find, but it takes time. Idea was what? Just writing it as n into A into B into C, which means all this entire number, 72 cube, 555 cube, etc. is equal of this. It's equal to this. Actually, if you evaluate this, you get exactly this value. From there, doing it is a lot more easier. Quickly, one of you tell me the answer for the second one, friends. Go to the second one. All of you go to the second one. Let me know the answer for the second one quickly. I want you to tell me the answer to the second one. Quick, without wasting time. Quick, second one. All of you, second one. Very good. Your answer is right. Very good. Answer is right. Yeah. So what is that? All right. Now, so again, all right. Now this is A. A is 91. Okay. What is B here? Minus 45. Okay. What is C here? Minus 46. Is A plus B plus C 0? Yes. All right. A plus B plus C is 0, because plus 91 minus 91 0. Okay. Therefore, how can I write this particular number? 3 times of 91 minus 45. I'll write it as 45, because minus into minus becomes plus, into 46. Now, what does author is asking? Author is saying that, man, when you divide this by 65, why don't you tell me the remainder? Why don't you tell me the remainder? Remainder is 0. All right. Now, because what is 65? 65 is 13 into, right, 13 into 5. What is 65 here? The 65, all right, 65 is nothing but 13 into 5. All right, 13 into 5. 13 divides this piece. 13 divides this piece. Right, 5 divides this piece. Therefore, the numerator, therefore, the number is completely divisible by 65. Thereby, your remainder becomes 0. Very good. All of you got this. Very good. All right, that's a question there. Okay, property number 3, high school property. High school property. If the sum is constant, if the sum is constant, A plus B, sum is constant, then product is maximum when A is equal to B. We all know this condition. We all know this condition. Given sum is constant. Say, for example, A plus B is equal to 25. Sum is constant, right? Product is maximum. It's real. It is real only, right? Now, product, what is the maximum value of the product? Trust me, maximum value of the product comes when you make A is equal to, when you make A is equal to B. Okay, let me change the number to 16. when you make a is equal to b. All right, therefore a is equal to b is equal to 8. Friends, this is the best answer that you can write. 8 into 8 is equal to 64. Nobody can ever get an answer better than this. All right, now whatever be the values of a and b that you write, all right, whatever be the values of a and b that you write, you can't get an answer better than this. You won't get an answer better than this, right? Yeah. So okay, similarly, when the product is constant, on the other hand, if you say that no, a into b is equal to 25, all right, a into b is equal to 25, then what is the minimum? All right, always it's a minimum, reverse. All right, here it was max, here it is minimum, right? Therefore you will say that a plus b, what could be the minimum value of this? That's a question we are asking. What could be the minimum value of this a plus b? Right, minimum value of this, of course. All right, now here what is the assumption? A, B are positive. Remember this, A and B are positive real numbers. So minima comes when A is equal to B. Again you say that A is equal to B is equal to 5. You can't write minus 5, friends, because it's given. All right, this property we are discussing only for positive real numbers. Don't try to write minus and try to get into some other purpose of the question, right? Yeah, it's not about that. It's a positive real numbers. Therefore A is equal to B is equal to 5. Therefore you are trying to say that okay, therefore the required result is 5 plus 5, 10. 10 is the minimum value. Or when the product is 25, you can't get an answer less than this. Okay, anyway, these two are pretty comfortable to us. That's about the property number 3. That's about the property number 3. Why don't you quickly get into this answer of this particular question, both the questions? Take 2 minutes. Take 2 minutes. Put the answer for both the questions out here. Quickly put the answer to both the questions. Good. Right? Yeah. Perfect. Perfect. The second one might have taken a little time for you. This is perfect. Right? A into B, A plus B is 90. Right? A plus B is 90. Therefore, you would have written this as sum is constant. Therefore, the maximum value of the product is maximum when A is equal to B, both equal to 45 each. All right, 45 each. What will be the maximum value of this product? All right, now when this happens, so therefore you are saying that the result is nothing but 45 square. 45 square, which is nothing but 20, 25. Right, 2025. Good. Next one, what will be the minimum value of this? Already, if P and Q is equal to this product is this, and P and Q are positive real numbers. This is a beautiful number, 7744. A lot of puzzles are also created on this particular number, my friends. 7744. 7744 is nothing but 88 square. All this is nothing but 88 square. It's a beautiful number. It's a beautiful number. Therefore, the required response is 84 plus 84. All right, because A should be equal to B. All right, now here P and Q. Therefore, P should be equal to Q, which should be equal to 88 because 88 square is this particular number. Therefore, all right, now you say that 88 plus 88. All right, 88 plus 88. That's a required response there, right, which is nothing but 176. Right, that would be the answer there. Okay, there is another beautiful number. Because we are talking about numbers, I will just introduce you to another number. This is the only number, 4-digit number, all it is only number in which three fours come together. This is 38 square. You better remember these numbers. 88 square you can remember, 7744. 38 square you can remember because it is 1 followed by 3 fours, right? 4 4 4. You rarely see this kind of phenomena, 3 fours coming together. Therefore, this is another special number. Sometimes the questions are created on this particular special number. Just like you might have known this, 145 factorial is also nothing but 1 factorial plus 4 factorial and 5 factorial. These are some special numbers. Basically, these are some special numbers, like in factorial is this. Likewise, okay, there are many. The idea is not about the class of special numbers. Just because I looked at 7744, another very frequent square that could come in the question is 38 square. Therefore, you need to be a little mindful about that. You need to be mindful about that. Good. Okay, so let's go further. Let's go further. Another special property here, friends. This is another very special, important special property. Okay, if you just go back to question number, if you just go back to the previous one, previous condition, and this, what is the difference here? All right, the difference is this. Okay, let me illustrate from here. Let me illustrate from here only. See, earlier you had a situation where you said that, all right, you said that x plus y is constant. Earlier the situation was this, my friends. The situation was, if x plus y is constant, if x plus, okay, let me write the analogical situation out here. If x plus y is constant, x into y is maximum, x into y is maximum when condition, this is important to me, x is equal to y. When x is equal to y. Now look what has happened here. Okay, so that was the earlier condition. Now what has happened here? Now this x has, the coefficient of x was 1. Here the coefficient of x is a. Coefficient of y is 1. Here the coefficient of y is b. Alright, therefore the coefficients are coming in the picture. Second one, the power of x is 1, but the power of x is p. Power of y is 1, therefore the power of y is q. Alright, power of y here is q. Therefore the condition here was x is equal to y. The condition was x is equal to y. Here, alright, now coefficient of x I should write here. This coefficient of x is a, write it here. The power of x write in the denominator. Okay, write this x. Write this x here. My point is, okay, write this x here. After this, write the coefficient of x divided by its power. Write the coefficient of y and divide by its power. Why? Because the coefficients were 1 and the powers were 1 earlier. But this time what is happening? Alright, no, this time what is happening? The coefficient of x is a. That is what you are writing here, coefficient. The power of x is p, and that is what you are writing it here. Power of x is p. Right? Yeah. Similarly, the coefficient of y is b. That's what you are writing it here. The power of y is q, and that's what you are writing it here. And that's what you are writing it here. Okay, that is my point here, friends. All right, that is my point here. I want you to remember this condition. I want you to remember this condition. All right, how you are writing it, I showed you. For example, if I write it something like this, hey, 2x plus 3y is equal to 10. And then I want you to understand that, okay, what would be x cube and y power 2? Or y power 5. X cube and y power 5. I want maximum of this. X and y are, x, y, a, b are all positive real numbers. Okay, they are positive real numbers. Therefore, all right, now what is the maximum value? What is the condition? Therefore, condition is simple, my friends. The condition is this. Write this 2x as it is. Write this 2x as it is. Divide by the power of x. Right, divided by power of x. Why this 2 here? Coefficient of x. All right, that also should be equal to. Write the coefficient of y as it is, which means copy this 3y as it is. 3y as it is, and divide by its power. What is the power of y here? 5. This condition should be satisfied. Earlier you used to write x is equal to y. Don't write x is equal to y. Rather write this particular condition. Similarly, if product is constant, the sum would be minima. Just like the product is maxima, the sum is going to be minima. What condition? Same condition. Ditto. Coefficient of x divided by the power of x. Coefficient. Write x here. Write its coefficient. Write its coefficient, divide by its power. Equate it. Write y here, multiply by its coefficient, divide by its power. Divide by its power. Write z here, write its coefficient and divide by its power. Divide by its power. This is the condition. Basically, this is the condition. Okay. All of you, I hope, sufficiently recalled. Hey, you technically study this in the 11th class. You don't study this in the 10th. This particular concept you study in the 11th class. But of course, it's one of the very important concepts for us. From our perspective, this is one of the important concepts. Okay, let's take a look at this particular question. Let's take a look at this particular question here. X square and y cube is equal to 8, where x and y are positive real. What is the minimum value of 4x and 3y? His question is, why don't you tell me the minimum value of this? Fine, I said that, okay, coefficient. What is the coefficient of x, my friends? Coefficient of x is 4. Write that condition. Therefore, the condition, evaluate the condition. What is evaluating condition? 4x divided by its power. What is the power? 2. Should also be equal to 3y. That is a coefficient of y is 3 divided by the power of y. What is the power of y? Is also 3. 3y divided by 3. Good. So therefore you would say that 2x is equal to y. In place of y, you can write it as 2x. In place of y, you can write it as 2x. Where will I write it? Go here. You can write it here if you want. You can write it here if you want. Let me get this down. So what is given to me? X square y cube is equal to 8. In place of y, I can write 2x. Let me write it x square. In place of y, I'm writing 2x, friends, and then I'm cubing it because there is a cube here which is also equal to 8. Therefore you are trying to say that, x power 5 is equal to 1, because 2 cube is 8, 8 and 8 got cancelled. X power 5 is equal to 1, therefore x is equal to 1. Therefore x is equal to 1. Now do what? Go back again. X is equal to 1. Substitute. What is given to me? X square y cube is equal to 8, in which the value of x is 1. Therefore 1 square into y cube is equal to 8. Therefore what is the value of y? Y is equal to 2. Technically now you got the value of x, you got the value of y. Now do what? Put them here. Let's go back and put these two here. Let 4x plus 3y, that is 4 times of what is the value of x? 1. 3 times of what is the value of y? 2. Put them together. Therefore you got the answer as 10. Therefore 10 is the answer for this question. The minimum value of 4x plus 3y is going to be 10. That's answer there. Okay, pretty important. What is most important thing out here? The most important thing is you should remember this particular condition. So you should remember this particular condition. See, I don't want to get back to your 11th standard trying to say that how you would have visualized those 5 terms, etc., etc. Not required for us. This is easier. Just remember this piece of condition. Rest becomes usual math, and you will close this question well within 2 minutes. I don't see a possibility of going beyond 2 minutes. It should take beyond between 1 or 2 minutes based on the pace at which you apply it. So, but if I know how to write my condition, it is sorted. All right, now, so what is the condition? Write x, write its coefficient divided by its power. Similarly, write y, write its coefficients and divided by its power. That becomes the condition. If you just apply this particular condition, you are sorted. Rest becomes just an usual math. Rest becomes usual math. Okay, if you got my point, or if you have got my point here, I want you to apply it in this particular question. Go ahead, friends, apply it. Go ahead, please apply it in this question. Let me know the answer. Please apply it, everybody. Please apply this. Apply this. Upload your copies. Apply it. Get me the response. Yeah, I'm sure you would have sorted. I gave about 2 minutes time because I said that that's a kind of time max it can take, right? Yeah, okay. So here we go. Here we go. This is the question. So 3 already he's saying that, okay, why don't you find the maximum value of this? The best value this can take. All right, coefficient of x, 3x divided by power of x, 2 is also equal to, that's a condition. That's a condition. Whenever they're positive and real, that's a condition. Okay. Then 4y, that's a number. Coefficient always comes with that this side, right? Yeah, 4 with its coefficient by its power. Okay, what is the power here? 3. This should be equal. Let this should be equal. This should be equal. So therefore you put the equal to sign there. This is the condition. This is the condition with which you work. This is a condition with which you work. Fine. So therefore from here, you also realize that 9x is also equal to 6y. So 9x is also equal to 8y, right? 9x is equal to 8y. That's a condition there. Okay, therefore what can be 4y? Either get the value of 3x or you get the value of 4y, whatever you can substitute for. All right, therefore what is the value of 4y? The value of 4y is nothing but 4.5x. Therefore you would say that this is going to be 4.5x. That's also fine. So what do I do with this? I will go and substitute it here. Therefore you write it as 3x. 4y can also be written as 4.5y is equal to 5. 3x plus 4.5y is equal to 5. From here you will say that 7.5x, all right, 4.5x here. Therefore 7.5x is also equal to 5. Therefore x is equal to 2 by 3. X is equal to 2 by 3 because you will be writing it as x 5 divided by 7.5, which becomes 2 by 3. That's a value of x there, 2 by 3. Okay, now do what? Now you know the value of x. Go back, substitute this in this particular equation. Once again, you get the value of y from there. All right, you would get the value of y from there. Therefore, you're writing this as 2 times of 2 by 3. All right, I'm substituting for the value of x, my friends, and then 4 times of y, which is also equal to 5. Good. All right, now therefore you are saying that 2 plus 4y is equal to 5. From here you would say that the value of y is nothing but 3 divided by 4. The value of y is nothing but 3 divided by 4. Okay, so now you are ready with the value of x here. You are ready with the value of here. Do what? Go back, substitute it here. Okay, what is the value of x here? 2 by 3. What? Whole square. Good. Hey, what is the value of y there? The value of y is 3 by 4. What? Whole cube. I can simplify. I can simplify based on the answer options how they have given. I will simplify and I will give the answer options once I reach this particular stage. Okay, that's about the crux of this. There is nothing to worry out here. There is nothing to worry out here. All I need to understand is, okay, I need to know the basic elements of this particular question. Once I'm clear about the basic element, what is the basic element? This particular condition. If I'm clear about this condition, I'm fairly sorted with this particular question. You're fairly sorted with this particular question. Okay, now here there is a second part of the question also saying that also find the value of x at which the above expression is maximum. Value of x, you know, that's a part of the question. 2 by 3. If they ask value of y at which it is going to be maximum, it is say nothing but 3 by 4. All those things can be answered. That's not a worry there. All right, that's not a worry. Okay, let's go further. Let's go further. Fifth one, am is greater than, again, for all positive and real numbers, for all positive and real numbers, am is definitely greater than or equal to gm, which in turn is greater than or equal to hm, right? Am greater than or equal to gm, which is also greater than or equal to hm. All right, now that is well known to us. All right, that's well known to us there. All right, that's known to us. So here I also want you to remember one thing. Maybe you would be knowing it. I'll just write it out here. The number and its reciprocal, x plus 1 by x is always greater than or equal to 2. When that equal to 2 would come, when x is equal to 1. When x is equal to 1, or that is when x plus 1 by x will be greater than or equal to 2. Another proposition, x plus 1 by x is always less than or equal to minus 2. When x is negative, when x is equal to minus 1. Alright, when x is equal to minus 1, this is always equal to less than or minus 2. Therefore, the number and its reciprocal will always be either beyond this, or it will be 2 and beyond this. It will never take the values between minus 2 and 2. That's another point. Well, it is a very trivial point what I made here, but I want you to remember this trivial point here. Okay, so what do you mean by am gm? If I take 3 terms abc or xyz, if I simply take 3 terms xyz as an example, you say that, okay, am of 3 terms is what? Positive and real. Let's say that xyz and positive real. X plus y plus z divided by 3 is always greater than gm is nothing but what? Cube root of xyz. Why? Because 3 terms are there, which is always greater than or equal to 3 divided by 1 plus x, 1 plus y, and 1 plus. That's what I meant. Simply I meant just 3 is an example, 3 terms is an example. Can there be many terms? Yes. Can there be many terms? Of course, yes. Well, it doesn't. 3 is just an example to this. And I also want you to remember this particular property along with this, because that also comes from am gm only, right? If one of the terms is x, if the second term is 1 by x, apply am on this, friends. Am greater than gm, apply am is greater than or equal to gm. You write x plus 1 by x is greater than or equal to under root of x into 1 by x. All right, by 2 is under root of this. Therefore, when you solve this, you get x plus 1 by x is greater than or equal to 2. Nothing but what? A subset of this property. Basically, a subset of am greater than gm property leads me to these results. Well, it leads me to these results. Okay, that's a little bit of a background here. Let's do a couple of questions quickly built on this. Apply it here, friends. Apply it here. Let's go here quickly. Apply this. Apply this. Good. Here there are 3 terms. So there are 3 terms. Terms are always separated by plus or minus sign, which we all know. I don't have to tell that. Where you learn the first time in algebra, where you come across the word term and you do a lot of exercises on this, class 6. I'm not kidding. Class 6. Maybe in some boards class 5, but never after class 6. In class 6 itself, they will write so many equations and they'll show you, tell the term, tell the coefficient. Oh, you do huge number of exercises on that. Therefore, when I tell the term, I'm sure that everybody is clear because you learn it at the age of 10 or 11 years. Somewhere between that 10 to 12 years, well, there will be a lot of drills you do on terms and you'll be pretty clear. Terms are always separated by the positive sign. Good, let's go here. 12 by x, 18 by y, and xy. Xy is one term. Therefore, you are technically trying to say that, man, there are three terms. There is a first term, there is a second term, and there is a third term. Technically, three terms are given to me. Now look, all right, now when this is given, all right, now so whenever there is a maximum minima, firstly condition is x and y are positive real numbers. They say something like this. All right, now and when they say that, okay, tell me the minima, terms will be minima provided their product is maximum. Now look at this. Hey, where is that positive sign? There is a positive sign here. Now look at that. AM is there, then greater than or equal to GM is there, greater than HM is there. Now look at this. All right, now these are the terms that I have. Now you got to understand that, hey, if there is a positive term, then it is to do with AM, then it is to do with AM. Then if it is AM, the author should have given the constant value for GM or constant value for HM. Check it out, my friends. Check it out. Hey, what if I take the product of these three terms, GM, let me check, or let me check for HM. You can check both in the exam because you may not be clear. T2, T3, all right, now let me take the product of them, 12 by X, and you are writing it as 18 by Y into xy, product of the term. Say, is the product constant? Of course, yes, the product has become constant, which is 216, or the product has become constant. Yeah, perfect. Right, now this has become 216. Very good. All right, the product is constant. Product is constant, then the sum is minimum. When the product is constant, the sum is minimum. When the sum is minimum, when all terms are equal, the first term should be equal to second term, which should be equal to third term. All the terms should be equal. Right, that is what the aim is. All right, now that's where the equal, the minima comes when all the terms are equal. Right, so therefore apply it. What is the first term? 12 by x is also equal to 18 by which also should be equal to xy. Use one of the equations, that is enough. X and y let me use. Right, x and y let me use here. So x and y, if I use, you will understand that, okay, therefore 12 by x is equal to 18 by y. In other words, x by y ratio, friends, x by y. In other words, you are writing this particular ratio. X by y will be of the form. All it x by y is of the form 2, 6, 2 times. Of course, 12 by 18 you will write. You will write this as 12 by 18, all right, which is nothing but 2 divided by 3. X and y. Therefore, the ratio of x and y is of the form 2:3. All right, x and y is of this particular ratio, which is nothing but 2:3. All right, 2:3. Good. So that's the ratio is 2:3, which implies what? X is of the form 2x. X will be of the form, or x will be of the form 2a. All right, x would be of the form 2a. Then y will be of the form 2b. All right, y would be of the form 2b. Something like this. That's a ratio. That's what you are trying to say there. All right, that's what you are trying to say there. Okay, get back to the number. All right, let's get back to the number. What is the minimum value of this particular expression? Author is asking about the minimum value of this particular expression. Right, minimum value of this. If I want the minimum value of this, the product was constant. Sum is minimum when this happens here. All right, sum is minimum when this happens here. Now do what? Take another two terms and equate it. Therefore, you are saying that, okay, 18 by y is also equal to xy. Let's say 18 by y is also equal to xy. Let's understand what is the value of y there. 18 by, what is y? You took it as 2b. All right, 2b. Very good. So what is that xy? You are taking it as x value, you know. Let's substitute. X value is nothing but 2a. All right, sorry, this is 2a and 3a, because the ratio is 2:3, right? Ratio is 2:3. Let me write it as 2a and 3a. That's the values. Okay, therefore you are writing this as 2a here. Writing it as 2a. Then the x is 2a. The y is 3a. All right, yeah, 3a. Y is 3a. Good. So therefore, you get the value of a from here. What is the value of a here, right? So you say that 18a cube, 18a cube is also equal to 18. Therefore, a is equal to 1. Therefore, a is equal to 1. Perfect. If a is equal to 1, you got the values of x and y. From here, you would say that, therefore, x is equal to 2 and y is equal to 3. Come back, substitute. 12 divided by 2 plus 18 divided by 3. All right, which is also equal to, all right, which is also equal to x plus y. That is nothing but 2 into 3. All right, you got these particular values. Therefore, you would say that, okay, this is nothing but 6 here. So this is also 6 here. This is also another 6 here. 2 into 3 is also another 6 here. Therefore, you would say that the response is nothing but 18. Right? Because each part should be equal here. Therefore, it is equal. Okay, my point, how is this different from whatever we were doing earlier? Earlier, they used to tell that the product is constant, sum is constant. In this question, what happened? You realize that the product is constant. It is you who realize that the product is constant, isn't it? It's you who realize this particular product is constant. Okay, now here, so what I also taught you is how to find the value of x and how to find the value of y. All right, because sometimes they may ask that tell me what is the value of x. Sometimes they may ask that tell me what is the value of y. I should know how to tell that, right? I should know how to tell that. Okay. Sometimes I have to assume that, like just like this particular question, hey, I just want the minimum value of this. I'm not interested what is x and y. Sure. If you are not interested, directly apply this. Okay, I'll remove this, my friends. Directly apply this particular concept and get to the result. Okay, I'll tell you what I meant by this. I'll tell you what I meant by this. So now you got to first realize that, okay, this piece of information is to do with AM greater than GM, because the probability AM greater than GM is what? First term, second term, third term divided by 2 is greater than or equal to cube root of first term, second term, and third term. Cube root of first term, second term, and third term. Okay, this is T1, T2, T3 divided by 3 terms. Okay, what are the T1, T2, T3? 12 by x plus 18 by y plus xy divided by 3 is greater than or equal to cube root of 12 by x into 18 by y into xy. What happened here? Xy got cancelled. Cube root of this is nothing but 6. Yeah. Okay, therefore you say that, hey, 12 by x plus 18 by y plus xy divided by 3 is nothing but this. Therefore 12 by x multiply, take this on the other side, 18 by y, all right, plus xy is greater than or equal to 18. Greater than or equal to 18 means what, my friends? Which means it can take from 18, it can go up to infinity. Therefore, what is the minimum value? If the number can go from 18 up to infinity, because greater than or equal to 18 means what? This expression can go from 18 up to infinity. So which means 18 is the smallest number. From 18 up to infinity, smallest value is nothing but 18. That is what you got this. So here what did you do? You didn't get the value of x. You are not bothered about the value of y. You did it directly. Now why did I teach the earlier method? What if they ask that tell me the value of x at which this expression is minimum? Then you should know how to get the value of x. Tell me the value of y at which this expression is minimum. Then we should know how to get the value of y. That is my core point. That is my core point. I taught you both the methods using this particular example, both the ways. All right, we're using one example. Fine, you solve this quickly. Now you solve this. You solve this whichever the method you want to do. You want to get the value of x, don't want to get the value of x, does not matter. Find the minimum value of this expression quick. Yeah, good. You might have sorted by now. It doesn't take much time. Two terms here. Therefore, this is the first term and you have the second term. Right? There are two terms out here. Right. So you may say that, okay, my first term is 4 power x. My second term is 4 divided by 4 power x. Law of indices. What is 4 raised to power 1 minus x? 4 divided by 4 power x. Okay. If I take the product, three things you will try. AM you will try. Follow it, because when you want to find maximum, minimum, AM greater than GM, HM, some constant should be there. He's asking all it. The plus means because of the plus sign, you know that it is AM. AM is there for sure. Should I look for GM or HM? That's what you got to think here. If I look at GM of these two terms, GM of these two terms is nothing but 4x into 4 divided by 4 power x. Cancelled, it has become a constant number. All geometric mean is root of this. Therefore, root of this, which is nothing but 2. It's nothing but 2. Perfect. All right, therefore, you got this as, all right, now positive and real. Therefore, you said the answer is 2. GM is constant. 2 means what? Basically, yours constant. Therefore, you say that, hey, I will apply AM greater than or equal to GM. Okay, what is AM, friends? 4x plus 4 divided by 4 power x divided by 2. That's two terms here. All right, two terms which should be greater than or equal to under root of 4x 4 power x and 4 divided by 4 power x, because there are two terms. This is my first term and this is my second term. Sum and the product 4 power x cancel. So therefore you will say that 4 power x and then 4 divided by 4 power x is greater than or equal to 2 into 2. All right, now this is 2 here. This divided by 2. Therefore 4x 4 power x divided by 4 times of 4 power divided by 4 divided by 4 power x is 2 into 2, which is 4, which becomes my answer. Because it says that, okay, the value tends from 4 up to infinity. What's the minimum value therefore? Minima is 4. Because can I write up to infinity? Of course, as you can write, right? Therefore, all the minimum value is nothing but 4. Because he didn't ask that what is the positive value, what is the value of x, where it will be. Let know where it will be. So that's a different issue. I told you how to reach that if you wanted that, but that's not required here. Therefore, this is my answer. All right, this is my answer in this. Okay, good. One last one on this, then I will change it to the next concept, one of the other important concepts after this. Let's try it out. Let's try this. Yeah, okay, fine. It's given that, okay, if it is I, that's x1 x2 up to 50 is also equal to 50. Yeah, what is this? This is sum. If this is sum, then there is an arithmetic mean. Yeah, what is this? If the terms are x1 x2, these are the terms. X1 is a term, x2 is a term. Yeah, what did I write? Reciprocal, 1 by x1 1 by x2. Then this is what? Harmonic mean. All right, therefore it will become a concept of harmonic mean. Therefore you will say that, hey, in this portion am greater than gm greater than hm, I'll say that, hey, I will take am versus hm. I will take am versus hm. How many terms? 50 terms. Good. Therefore, you are writing x1 plus x2 up to x50, up to x50, right? Divided by 50, because 50 terms is greater than or equal to 50 divided by 1 by x1 plus 1 by x2 up to 1 divided by x50. Oh, very good. All right, now this is what you have. So now all of them are positive real numbers for all xi greater than 0, which means what? For all the values of this greater than, all it, which means the values are greater than 0, x1 is greater than 0, x2 is greater than 0, and so on. Okay, so what is this value here? X1 x2 x3 here. What is the value of this here? 50. Therefore I can write this as 50. What is 50 by 50? 1. Therefore you are now trying to say that 1 by x1, bring this on the other side. All right, 1 by x1 plus 1 by x2, all right, likewise up to 1 by x50, let plus, all right, 1 by x50 is greater than or equal to how much? 50, because this 50 remains, this a 50. That's your answer, which means you are trying to say that this expression can take 50 onwards, or at 50 onwards up to infinity. Therefore, what is the minimum value, my friends? Minimum. The minimum value of this expression is going to be 50. Perfect. All right, that's a simple example. In sense, what I'm trying to say is, hey, look for the elements. Sometimes am, sometimes gm, sometimes hm. Look, all right, now what is more beneficial to you between all of this? All right, what makes better sense to you? So based on that, how do you understand this? By looking at the elements of the question. Are there reciprocals? Is there addition sign? Well, no. Can I check whether the multiplication becomes a constant number? These are the small things that you check to realize that which two components out of the given three components I should use. All right, there are three known components. Which two components I should use to resolve this particular issue? Right? Yeah. So these are some of the types of the questions. Next one, next important concept. We'll go to integral solutions. Linear, also there is a quadratic. Two types of question come: integral solutions, linear and quadratic. Let's see in the next 20-30 minutes what best can be done. We'll try and do the best that is possible. Okay, here we go. Here we go. First part is what? The positive ax plus by is equal to a natural number, Questions are either they ask for, give me the positive integral solutions of xy. First remember this, positive integral solutions of xy, or they may ask for non-negative. These are most popular questions, two popular types. Not under the linear, right? Under the linear, non-negative integral solution of xy. Non-negative integral solutions of xy pair. All right, one, either they may ask often about the positive integral solutions of xy pair, or they may talk about the non-negative integral solutions of xy pair. These are the two very popular. I'm not saying that these are the only two questions which come whenever they give the equation of this particular form, ax plus by is equal to n. So these are the two popular types. Okay, what are these ax plus by? A is positive, a, b are positive, they're positive, and they are natural, positive natural number. The natural numbers a, b are natural. Okay, let me put it like this: a, b, n are natural numbers. ABN or natural numbers. Therefore, now I'm talking about what? Hey, I'm asking, is X and Y are also positive real, or X and Y are non-negative? Non-negative integers. Non-negative integers. Basically, we're talking all integers. A is an integer, B is an integer, N is an integer. All right, but A, B, N are not just integers, they are positive integers. Now, what about X and Y? I'm talking about X and Y becoming integers. What kind of integer? Either positive integer or non-negative integer. Okay, there are three cases which come between this. There are three types which come between this. What is this? Both A and B divide N. A divides N here. In the sense, coefficient of X divides N. Coefficient of Y also divides N. That is one type. Okay, why these types? I'll come to that. Okay, second one. One of them will divide. Either A divides or B divides, which means the coefficient of X, if it is dividing, coefficient of X is dividing, then the coefficient of Y does not divide. The Y does not divide. Reverse. Oh no, coefficient of Y is dividing, then the coefficient of X need not divide. That's a type 2. All right, that is the type 2. Okay. What about the type 3? All right, type 3 is neither of them divide. All right, type 3 is neither divide. Neither. Both A and B not divide, which means neither A divides N nor B divides N. In the sense, no coefficient of X does not divide. The coefficient of Y also does not divide. Okay, so these three cases, what's the advantage? What is that we want to understand? Now listen to me carefully. Let us take this example here. Let's take this example here. 3x plus 4y is equal to 48. Now listen to me carefully, friends. First, always check, does the coefficient of X divide? Just check coefficient of X divide, or does the coefficient of Y divide? Just check them. Okay, X only is dividing. If the moment X is dividing, put Y 0. If you think that the coefficient of X divides, if you think that coefficient of X divides, the coefficient of X is already dividing it, simply put Y is equal to 0. Simply put Y is equal to 0 and get the best value, maximum positive integral value of, because I'm talking about what? To non-negative integral values, it has already become non-negative. 0 has become non-negative. Simply write 0 because the coefficient of X divides. Simply write 0 for Y. Simply write 0 for Y. Okay, I wrote it. And then what now do? Now get the best value for X. If Y is 0, now it has become 3x is equal to 48. Therefore, X is equal to 60. X is equal to 16. So write it here, 16. What is this 16, friends? It's a corresponding pair. You are trying to say that 16 comma 0 is a solution set. Put X is equal to 16, put Y is equal to 0. You get a solution set. Now listen carefully here. From here you listen carefully. So you can write the remaining solution sets very easily. Why? Because it will be in arithmetic progression. This series, all right, I can keep writing the numbers here down, the set of numbers, all right, which would be in AP, arithmetic progression. Difference will be constant. Now what is the common difference? The common difference here is coefficient of X. What is the coefficient of X? 3 here with a plus sign. Okay, so all right, now wherever you are written 0, that will have a coefficient, that would have a positive reference, that would have a positive. All right, now that would have a coefficient of X with a positive sign. Okay, so here what is the common difference for the next series here, this particular series? You said AP. What is the common difference here? The common difference becomes the coefficient of Y. What is the coefficient of Y? 4. With what sign? With a negative sign, because sum is constant, right? Now look, 3x plus 4y, that is the sum. Sum is constant. If Y increases, then X has to decrease, my friends. Then X has to decrease. X has to decrease. You can't say that, hey, both are increasing and the sum is constant. Come on, how is it possible? That's a miracle. Both X and Y are increasing, yet the sum is constant. That does not happen in math. If the value of Y is increasing, then the value of X should decrease. The point is, why did you say Y should increase? Because this is at the minima. X is equal to Y is equal to 0 is the minima. Hey, why you are saying minima? Now look at the first question, non-negative integral solution. What is the smallest non-negative integer? 0. The smallest non-negative integer is 0. Therefore, you already wrote 0 there. So because you already wrote 0 there, it's at its minima. So when Y is at its minima, what about X? X is at its maxima. It's at its maxima. Now write the corresponding pairs, my friends. Therefore, let's write the corresponding values out here. Let's write the corresponding values. So if I want to write it manually, then how does it look like? Let's check. Right, manually, if I'm writing, how does it look like? Add 3, therefore it becomes 3. All right, this would become 3. Add another 3, it becomes 6. Add another 3, it becomes 9. And it goes on. Very good. Okay, here this side, subtract minus 4 because the common difference is minus 4. All right, therefore it becomes how much? 12. My point is what? Okay, so if you put X is equal to 12 and Y is equal to 3, you still get 48 in that equation. All right, 12 3 times 36 plus 4 3 times 12, which became 48. Or next is what? Okay, again reduce it by 4. Common difference is minus 4. What is the next term here? Next term is 8. 8 comma 6 is also a solution set. The next one is what? All right, next one again reduce it by 4. All right, it becomes 4 comma 4 comma 9. Hey, what about the next set here? Next set here is going to be 12 because plus 3 we're adding. Hey, what about this? This becomes 0 and stop. And stop, because already this has become 0 here, because you cannot write the next term saying that, hey, I will write minus 4 there, not required. Minus 4 there, not required. Therefore, if you say that how many positive integral solution, one pair, there is a second pair, third pair, fourth pair, and fifth pair. There are 5 pairs of non-negative integral solutions. 5 pairs. 5 pairs, technically 5. You don't have to write the word pairs, right? Yeah. How many positive integral solution? This is one, this is the second one, and this is the third one. There are 3 positive integral solution, because the first one cannot qualify because there is a 0 here. Because of 0, it cannot qualify as a positive integral solutions of x and y. Last one cannot qualify because of the plus 0. Because of 0 there, even that cannot qualify. I hope all of you understood this. Okay, what are the concepts involved here? The concepts involved is, first understand, if one of the coefficients divides this 49, whichever is that, okay, whichever one divides, you may say that, hey, here 48 is also 4 is also dividing. Fine, put x is equal to 0 and proceed. There is absolutely no problem. Which means, would I have done like this? For 3x plus 4y is equal to 48. I realize that 4 divides. Yeah, then put x is equal to 0. Put x is equal to 0. You will get the best value of y. Therefore, 4 into something is equal to 48. All right, 4 into something is equal to 48. 4 into what is equal to 48? 4 into 12. Where did you start? You started here. You came here directly. So you are writing this entire matrix in the reverse order this time. That's it, because you started on this note, 0 comma 12. This is where the 0 comma 12 is. That's it. So which way you do it does not matter to me. One of them you have to quickly write it as 0. That is the beginning part of this particular game. The moment you write one of them as 0, or let one of them as 0, you'll start that game. Then immediately you realize that, hey, it's an AP series. Therefore, what are my common differences? Wherever it is 0, the only way forward is positive. Positive times of common difference you will write. This side you will write the negative times of common difference. What is this common difference? Common difference is nothing but the reverse coefficients. Put these coefficients in the reverse order, you got that common difference. In the sense, if you would have written it 0 and 2 here, already you would have written this as, already now here you would have written plus 4, already here you would have written minus 3. Alright, here you would have written minus 3. So therefore you would have said that, 4, 8, 12, 16, 20, and so on. On the other side, the common difference of minus 3, you would have written this as 9, 6, 3, 0, minus 3. But I'm not interested in this. I would have stopped it here. The moment I got 0, I will stop it. Alright, the moment I get 0, I'll stop it. Okay, very manually I explained this entire process out here. Very manually explained this process out here. Very good. Alright, so therefore you got your answers, 5 pairs and 3 pairs. 5 and 3 are the answers here. Fine, now listen, what if, all right, now the range is pretty far and wide. Okay, so while you are doing this, all right, positive and real. Now this can also be done like this, my friends. Listen to me. If the expression is of the form ax plus by is equal to n, in which a and b are co-primes, in which, listen carefully, a and b are co-primes, in which a and b are co-primes. All right, in which a and b are co-primes, and a and b are co-primes, and one between at least one among a comma b divides n. A comma b divides n. Then the number of non-negative integral solutions. Then the number of non-negative integral solutions is given by n divided by a into b, quotient. Quotient, that square bracket means quotient, plus 1. All right, plus 1. I want you to remember this piece of information. This piece of information, I will repeat once again. If the structure is ax plus by is equal to n, in which a and b are co-primes, right? Yeah. Then at least condition. What is the condition? At least one among a and b divides n. Then the number of non-negative integral solutions is given by n divided by a into b plus 1. It is given by this. Yeah, can I apply this particular question here? Let's see this. All right, what is the value of n, friends? Yeah, the value of n is nothing but 48. Yeah, what is the value of a? 3. What is the value of b? 4. Okay, so therefore, number of non-negative integral solutions. I would have directly done it here by using this. Therefore, you would say the number of non-negative integral solutions, I don't know about positive, number of non-negative integral solutions is equal to 48 divided by 3 into 4. 48 divided by 3 into 4 quotient plus 1. Okay, 12, all at 4 into 3 is what? Divide it, write the quotient part of it. 12 fours are 48. Therefore, you say that 4 plus 1, 5. Earlier also you said the same thing, 5 pairs. Very good. Hey, from here, how do I understand that number of positive integral solution? Listen carefully, friends. Number of positive integral solution is 5 minus. I'll now ask a question. Does the coefficient of x divide? Let ask a question. Does the coefficient of x divide it? Yes. If the coefficient, does the coefficient of x divide 48? Answer is yes. 3 divides. Therefore, minus 1. Minus 1. Okay, ask the second question. Does the coefficient of y divides 45? Answer is yes. Therefore, another minus 1. Therefore, number of positive integral solutions are 3. Number of positive integral solutions are 3. Simple. All of you understood this method, I guess. All of you would have understood this. Let's go to the next one. Let's go to the next one. Apply whichever method you want. Apply whichever method you want. Get me the response, my friends. Get me the response to the first two questions. Get me the response to the first two questions. First two questions, all of you. Right? Okay. I give sufficient time to do first two parts. First two parts, I give sufficient time. Okay, let's take a look here. Let me do by both the methods to illustrate this point here. So firstly, 3x plus 5y is equal to 48. First understand, does any of the coefficients divide? Does 5 divide 48? Answer is no. Therefore, leave it. Does 3 divide 48? Answer is yes. So therefore, what you do? Put this 0 immediately, because you said that hey, 3 divides 48. 3 divides 48 sentence. 3 divides 48. Therefore, quickly put y is equal to 0. Fine. I put y is equal to 0. Once you put y is equal to 0, get the best value of x. All right, now that's nothing but 12. That's nothing but 16. You got the best value there. Therefore, this is at its max. This is at its maxima. Therefore, this is at its minima. All right, this is at its minima. Good. Okay, how do you write the next values here? Therefore, this would be with an AP of minus 5, a common difference of minus 5. This would be with a common difference of plus 3. All right, reverse coefficient, reverse. A y plus, because it is at minima. Whatever is at minima, it has to grow from there. There is no choice. Therefore, what is the next set here? 3, 6, 9, 12, and so on. Hey, what about the set on this particular side? You would say that hey, this is nothing but, okay, this is nothing but 12. Sorry, not 12, minus 5, my 11 minus 5, all right, which is nothing but 6. 6 minus 5, which is nothing but 1. A 1 minus 5, which is nothing but minus 4. I'm not interested at minus 4. Here I am not interested. Therefore, you said that okay, there are 4 solutions, and this is fine, the second is fine, the third is fine, and the fourth is fine. These are the 4 sets. Well, these are the corresponding values of x and y, right? Corresponding values of x and y. So from here, all it you would say, all right, from here you would say that okay, so therefore, so they all it knows, therefore the number of positive non-negative integral solutions are 4. 4 pairs. Number of positive integral solutions, I got to discard the first pair. Why discard the first pair? Because there is a 0 here. Therefore, you will say that number of positive integral solutions are 3. Method 2, what did I teach you there? All right, there is 3x plus 5y is equal to 48. Are these two numbers co-prime? Yes, they are co-prime. Okay, so does at least one of the numbers divide 48? Second condition? Yes. 3 divides 45. Both need not divide. At least one of them should divide. Does 3 divide 48? Yes, it divides. Therefore, you would say that the number of non-negative integral solutions is n, that is 48 divided by 3 into 5. What I should take here? Quotient. plus what? Plus 1. Okay, so 15, therefore it is nothing but 3. 3 is the quotient. 15, 3 times 45, right? Quotient, remainder is 3. That does not matter, friends, right? Quotient plus 1, which means 4. That's the number that you wrote. This is 4. 4 is the answer. Good. Find the number of positive integral solutions. Good. Positive integral solutions are 3, because what did I ask you to do there? I said that, okay, go back to this 3x plus 5y is equal to 48. So now you're writing number of positive integral solution. Start with this 4 first. 4 minus. Should I subtract anything there? Okay. Does 3 divide 48? Does 3 divide 48? Yes. Therefore, one subtraction. Does 5 divide 48? No. All right, therefore no more subtraction. No more subtraction. So that at the most you'll be able to subtract 2 of them. You don't have to subtract. Therefore you said that the response is nothing but 3. Therefore 4 minus 1 is also equal to 3. 4 minus 1 is 3. All right, that's a response that you got there. Okay, so good. Let's go here. Let's take a look at this question. Third one, because sometimes you get like this. Find the number of integral solutions such that x lies between 0 and 100 values of x, because now he is not saying that, okay, positive or negative integer. Now he is saying integral solutions. Find the number of integral solutions which satisfy this equation such that the value of x lies between 0 and 100. Perfect, friends. All right, now that should lie between 0 and 100. Now listen to me carefully. So how do I get this done? All right, how do we get this done? So we know that, okay, one of the values, all right, now we'll write the minimum value of x here. So go back to this and deliberately write the minimum value of x. All right, deliberately write the minimum value of x here. What do you mean? So what you do here is, all right, what you do here is deliberately write the minimum value means put x is equal to 0 and check whether 5y divides 48. This 5y, does 5y divide 48? All right, 5y equal to 48, where y is an integer. No. Okay, put x is equal to 1. Put x is equal to 1. So therefore 5y is equal to 45. Is y an integer? Yes. Is y an integer? Yes. All right, now y an integer? Yes. Therefore, what is the smallest value of y? Smallest value of x? 1. Because x should lie between 0 and 100. Fine. Minimum value of x is what? 1. Hey, what is the common difference, friends? Common difference is coefficient of y. What is the common difference here? Plus 5. Hey, why plus 5? Because this is already at its minimum. The only way forward is to grow. Therefore, what is that you are trying to say? I can go up to 100 with the stages of what? Plus 5. With the stages of what? Plus 5, which means the first term is 1. The x values you are writing. What is the second term? Add 5, it becomes 6. Hey, add another 5, already it becomes 11. Add another 5, already it becomes 60, and so on till you go to 100. How many terms you can write? That's a question author is asking. That is the question is author is asking. Very fine. All right, I will write the nth term. Nth term should be less than or equal to 100. So how do you write this here? So you look at this one and you will say that my nth term should be less than or equal to 100. Okay, define the nth term. What is nth term, friends? A plus n minus 1 times of common difference is less than or equal to 100. Nth term of an AP. Nth term of an AP is A plus n minus 1D. We all know. A, why less than 100? Because the condition is less than 100. Here the condition is less than 100. All right, here the condition is less than 100. Therefore, you took this 100. So A plus n minus 1D is less than or equal to 100. Good. Hey, what is the first term? Do I know the value of A? Yes, value of A is 1. Value of A is 1. So then you are writing n minus 1. Do I know the common difference here? Yes, you know common difference. Common difference is nothing but plus 5. Good, 5 is less than or equal to 100. Good, okay. So therefore, n minus 1 times of 5 is less than or equal to 99. Therefore, n minus 1 is less than or equal to 19.8. Okay, therefore n is less than or equal to 20.8. So therefore n is nothing but what? Integral values. N can be equality. N is nothing but number of terms you're talking about. N can be 1, 2, 3 like this. N cannot be 20.8. Therefore, what is the value of n you should take? Therefore, you will say that n is equal to 20. Therefore, you would say that n is equal to 20. There are 20 terms. All right, now so therefore, how many integral solutions for x lying between this? You are saying that 20 solutions. 20 solutions. Okay, I showed the steps. So point here is, okay, I showed you how to write this. How to write this piece of information, because whatever be the complexity of the question, once you know how to write this piece of information, you can solve. You can solve mentally, physically, whichever way that you want to solve does not matter to me. But you can solve it like this. All right, you can solve about the type 2. Now, what about the type 3? Type 3, because neither of them divide in the type 3. When you go to the type 3 here, so neither 3 divides this particular number, nor 5 divides this particular number. Therefore, only method 1 works. Therefore, you should strictly apply the method 1. Method 2 may give the right result. What is the method 2? Method 2 is nothing but n divided by a into b quotient plus 1 gives the number of non-negative integral solutions. May work, may not work in this case. It may work, it may not work in this particular case. Alright, it may not work in this particular case. Okay, I'll do the first 2 questions using the method 1. Alright, using the method 1, I will do first couple of questions. Okay, so what do you do here? Again, 3x, or you write it as 3x plus 5y is equal to 43. Go manually, because already you check that it does 3 divide this, answer no. Okay, does 5 divide this, answer no. So therefore, how should I start this? Start with this, put 0 here, put 1 here, because 0 did not satisfy 1. So therefore 5y is equal to 40. Oh good, if 5y is equal to 40, then y is equal to 8. Therefore that is the what? Maximum value. Y is equal to 8. You are writing this. Okay, this is 8, this 8 is maxima. Why do you call it as maxima? Because the value of x was minima. The value of x was minima. My point here is what? My point here is whenever none of the coefficients divide, start plugging the values. Put x is equal to 0, put x is equal to 1, put x is equal to 2. Quickly put it in your mind and check that okay, one solution pair is working. Once the one solution pair work, your composition remains same. This goes with plus 5. Alright, this starts going with minus 3. Already AP. So how is that minus 3? From here. How is this plus 5? From here, which I already explained to you. Therefore, you would keep working on this, saying that, okay, here it is going to be minus 3. That is nothing but 5. And this is nothing but from there minus 3. Therefore, it becomes 2. Again, minus 3, minus 1. Not interested at this point in time. Okay, and then further, you'll be working on this. Therefore, therefore, you'll get 6 here, 6 plus 5, 11 here. You got 3 sets of solution. That's 3 sets here. For this also 3. I showed you how to work on this using the inequality. You can work with that. Alright, you can work with that. 2 independent equations you can solve, because one of the values of y you know already. You can start anywhere. One of the initial value a can be anything, nth term. Alright, now this you solve one side, this you solve the other side. Club both of them just like you did in the previous question. You said 1. Alright, 1 inequality you solve both the sides, because there are 2 inequalities. Because this side it was 0, did not matter. Therefore, you solved only for one side. Here what you should be doing, solve it for both the sides. Solve it for both the sides. 2 inequalities you solve, and then club both the answer solutions. Become the number of values y can take. Number of values y can take. Okay, I will truncate this here so that I can do one of the CAT questions for you. Sometimes these are all the CAT questions. Okay, now the point here is how does the CAT question come on this? That's a point here, right? How does the CAT question come on this? I just put it in a very raw sense. CAT need not ask question in this raw sense. What they can do is they'll say that a person brought X number of pencils. X number of pencils. Under the person, or some pencils, they will say some pencils, you call it as X. The person also brought some erasers. Okay, what is that? Y. Now pencil cannot be cut and given in the class, cut and given in the shop. X pencil means X is a positive natural number, because all it now you will say that positive integer, because X pencils, because it cannot be negative also. He brought Y erasers. That also has to be positive integer, because you are saying that he brought Y erasers. Very good, Y erasers. And then all it knows, so what the price of each pencil is ₹3. Solid pencil is ₹3 pencil. The price of each eraser is ₹5. ₹5, and he totally spent total amount spent by him is ₹43. So now technically you write this equation. That's what you write, in which x and y are positive integers, because you are saying that he brought pencils and he brought erasers. You are technically doing the question B. You are technically doing question B. Now this is how the question comes. In the sense, there will be some words. Ultimately you get this and you realize that, man, one equation, 2 variables, how can I solve? Author knows that you can't solve, but he is telling that look, x and y are natural numbers. X and Y are natural numbers. He's giving that idea to you. So therefore he's saying that I'm not asking one solution. I know find the number of solutions, because I know one solution is not possible. He can spend this 43 rupees in many ways. Tell me how many ways he can spend, provided each pencil costs 3 rupees, each eraser costs 4 rupees, and therefore naturally he don't say that a pencil and pens are the natural numbers. We know they are natural numbers. Therefore you end up in this situation. That's what I mean. I showed it in a very raw form, because I don't want to write those sentences and again try to all know to read them, do them. Instead I said that okay, if I teach you how to solve this kind of equation, rest you can always create that equation and solve it in the exam, right? Solve it in the exam. Okay, one of those similar situations which came in CAT. All right, now sometimes you find 3 variables also. Sometimes you find 3 variables also. Let me just quickly tell you, okay, with 3 variables, what do I do? All right, sometimes 3 variables. There are many ways, but let me give at least the basic idea on this at this stage of time. Let me give the basic idea. It was something like this. A person has ₹50 notes. It's a currency note. He's keeping in his pocket one full bundle of rupees 50 notes, a bundle of rupees 10 notes, and a bundle of rupees 1 or 1 notes. Assume that 1 notes were there some time back, but that's when the cat question had come here. Right now, rupees 50 notes were there, rupees 10 notes were there, rupee 1 note were there. He went to a restaurant, all right, and then all right, he had something there. The bill amount, total bill amount came to be rupees 107. The total bill amount came to be rupees 107. The point is in how many ways he can pay. There are enough 50 rupee notes, there are enough 10 rupee notes, there are enough 1 rupee note. He want to tender exactly this money, no more no less. You may say that, hey, let him give 110 and then all it knows, so tips, so they will give back the money. No, he want to give exactly 107 rupees, no more no less, all right, by using whatever the money that he has, all right, whatever the money that he has, right? Okay, 3 cases, my friends. So how do you make the cases here? You look from this 50 and make the cases. The case 1, because suddenly you understand that, hey, there are 3 variables, isn't it? Correct, there are 3 variables. But I taught you how to solve an equation for two variables. Now suddenly there are 3 variables. How do I do this? So you have to make the cases. Case 1. All right, case 1. He uses 2. All right, he uses 2 rupees 50 notes. Case 1. Okay, case 2. You would say that case 2. He uses 1 rupee 50 note. Case 3. He uses no rupee 50 note. 3 cases, fine, done. So each case I can solve. If he uses 250 rupee notes, what is the remaining amount here? Assume that, okay, he will use X 10 rupee notes and he will use Y 1 rupee notes. All right, assume that X, Y rupee notes, and so therefore the remaining equation is what? 10x plus 1y is equal to 7 rupees. Hey, why 7 rupees? After giving 250 rupee note, you have to pay 7 more rupees. That is one way. That is one way. Hey, what do you mean by one way? Just give 7 1 rupee coins. That's it, because you can't even use the 10 rupee coin, 10 rupee note here. Just give him 7 1 rupee notes and it's done. One way. Okay. Second one, when you use 150 rupee note, which means out of 105 rupees, 50 rupees is gone. How much is left? 57 rupees is left. Therefore, 10x plus 1y is equal to 57. I have to find the number of integral solutions for this, because what are x and y? X and y is nothing but number of currency notes. You cannot cut and give the currency note. Therefore, x and y are natural. X and y are whole numbers. Let x and y are whole numbers. Okay. So therefore, how many whole numbered, so non-negative integral solutions for this? We know that, hey, does one of the coefficients divide 57? 10 does not divide, but 1 divide. If 1 divides, apply it. Therefore, number of non-negative integral solutions are 57 divided by 10 into 1 quotient plus 1. 57 divided by 7, 5.7. Take 5 plus 1, 6 ways. Therefore, 6 ways he can pay this bill. Last one, my friend. Similarly, the last one here. No 50 rupee notes. Oh, okay. Therefore, everything he's paying in terms of 10 rupee and 1 rupee denomination. All right, which is equal to 107. Again, 1 divides this. If it 1 divides this, I can use this. I can use my learning. Therefore, 107 divided by 10 into 1, the coefficients of x and y. All right, quotient plus 1. All right, therefore, this is 10 plus 1, 11 ways. Totally how many ways, my friends? 11 plus 6 plus 1. All right, therefore, you are saying that totally I can pay this bill in 18 ways. In 18 ways, this particular bill can be paid. Simple question, beautiful. So in the sense, what I'm trying to say is, you may suddenly come into a situation of 3 variables. Don't panic, make the cases. Make the cases. All right, that's what they meant. They will give only fewer cases, 3 4 kind of cases. All right, 3 4 kind of cases will be there. That's one way of tackling this particular question. All right, tackling this particular question. I hope I'll stop my inputs here. I guess all of you enjoyed this so far, in the sense, like, all of you learned through this particular lecture. Sure, I can talk about the quadratic, etc. When the time permits, surely I will come back. We'll talk about the quadratic inequalities, and little more are there when it comes to 3 variable inequalities. 3 variable, basically, one here, second one here, third here. There are some more techniques built on that. We will come back to that. I hope whatever I said so far, try and make use of this and try to solve as many questions in this area as possible. You'll be definitely able to enhance your understanding from here and then build further from where I'm stopping here. So this should have set a firm foundation for you. From this foundation, try and build it further. If you solve about 30 to 50 odd questions on this quickly in the next 1 or 2 days, of course, most of you would be on leave or definitely taking a little time out, because we are 30 days to CAT or whatever. So therefore, considering that, if you spend sufficient time, I'm sure in 2 days time, you will develop good amount of breadth and depth on this particular topic. If time permits, towards the end of it, I'll come back and give little more inputs about some of these particular areas. But let's see already if time permits at the end of it. Right? Yeah, here we go. All right, this is my input on the inequalities for today. So I'll come back to you with the remaining lectures on the quantitative aptitude. Bye till then. I will see you in the next lecture.